there is a dark mass on the Djoser Plateau, roughly 2 kilometers south of the Red Pyramid, roughly 3 kilometers south of the Bent Pyramid, that looks less like a pyramid and more like a wound in the desert. It is a low, eroded mound of blackened mud brick and crumbling limestone, its original shape almost entirely obliterated by the combined forces of rain, wind, groundwater, and the slow, patient work of nearly 4,000 years of decay. It does not gleam, it does not tower, it does not command the horizon the way its old kingdom neighbors do. It slumps, it sags, it dissolves, year by year, into the desert from which it was built, a structure that was designed to last for eternity, but that began failing before it was even finished. This is the Black Pyramid of Amenemhat III, and it is one of the most important and most overlooked monuments in the history of Egyptian architecture, not because it is beautiful, not because it is impressive, not because it succeeded. The Black Pyramid is important because it failed, and the nature of its failure tells a story that is more revealing and more unsettling than the story of any successful pyramid. The story is about knowledge, about what happens when the knowledge that built the greatest monuments of the ancient world is lost, when the institutional memory that sustained the pyramid-building tradition for centuries fades and is forgotten, and when a later generation of builders attempts to recapture the achievements of their ancestors with resources and techniques that are fundamentally inadequate for the task. The Black Pyramid was built roughly 800 years after the Great Pyramid of Giza, 8 centuries of political upheaval, social transformation, and institutional change that separated the confident mastery of the 4th dynasty builders from the diminished capabilities of the 12th dynasty pharaohs. 800 years in which the knowledge of how to build in solid stone, the knowledge that had been accumulated through decades of painful experimentation at Meidum, Djoser, and Giza, was gradually attenuated, diluted, and eventually lost. The Black Pyramid is the physical evidence of that loss, a structure that demonstrates, in the most concrete and most permanent way possible, that the knowledge which built the Great Pyramid was no longer available to the builders who attempted the Black Pyramid, and that the absence of the knowledge had consequences that were visible, structural, and ultimately fatal to the project. The numbers are striking. The Great Pyramid stands 146 meters tall and has endured for 4,500 years without structural failure. The Black Pyramid was designed to stand 75 meters tall, roughly half the height of the Great Pyramid, and it began failing during the construction itself. The Great Pyramid was built of solid limestone blocks, millions of precisely cut stones that were placed with a precision measured in centimeters. The Black Pyramid was built of mud brick, sun-dried bricks of Nile mud that were plastered over with a thin veneer of limestone casing. The contrast between the two structures tells the story of what happened to the Egyptian building tradition in the 8 centuries that separated them. A story of decline, of loss, and of the fragility of the institutional knowledge that sustains great civilizations. By the end of tonight, you're going to understand the story of the pyramid that proves the most important lesson of the ancient world, the lesson that knowledge, once lost, cannot be rebuilt by ambition alone, the lesson that the greatest achievements of human civilization are sustained not by the monuments themselves, but by the institutional knowledge that created them, and the lesson that the failure to maintain that knowledge leads, inevitably, to the failure of the monuments that the knowledge produced. Before we get started, if you find these mysteries as fascinating as we do, take a second to like the video or subscribe. It is a simple action, but it genuinely helps this channel reach more curious minds like yours. The Black Pyramid sits on the same plateau as the Red Pyramid and the Bent Pyramid, the monuments of Sneferu, the pharaoh whose experimental building program had generated the knowledge that made the Great Pyramid possible. The proximity is both geographical and symbolic. The Black Pyramid stands within sight of the structures that represent the peak of the pyramid building tradition, a constant reminder of what the tradition had once been capable of and of what it had lost in the 8 centuries that separated the 4th dynasty from the 12th. The proximity makes the comparison inescapable. The visitor who stands at the Black Pyramid and looks north toward the Red Pyramid sees, in a single glance, the distance between knowledge maintained and knowledge lost, between a tradition at its peak and a tradition in its decline, between a civilization that knew how to build in stone and a civilization that had forgotten. The name itself, the Black Pyramid, carries a weight that the names of other Egyptian pyramids do not. The Great Pyramid is named for its size. The Bent Pyramid is named for its shape. The Red Pyramid is named for the color of its core blocks. The Black Pyramid is named for darkness, for the dark, weathered surface of its deteriorating mass, for the somber color of the basalt pyramidion that once crowned its apex, and perhaps for the shadow that the structure casts over the history of the pyramid building tradition, a shadow of decline and loss that falls across the centuries that separate the confident mastery of the Old Kingdom from the diminished capability of the Middle Kingdom. Now, let's begin. To understand the Black Pyramid, you must first understand the 8 centuries that separated it from the Great Pyramid. 8 centuries that transformed the Egyptian state, the Egyptian building tradition, and the relationship between the pharaoh and his monuments in ways that would have been unrecognizable to the builders of the 4th dynasty. The Old Kingdom, the period that produced the Great Pyramid, the Sphinx, and the most impressive monuments of the ancient world, collapsed around 2150 BC, roughly 4 centuries after the Great Pyramid was completed. The collapse was not sudden. It was a gradual process of political decentralization, economic decline, and institutional fragmentation that extended over several generations and that eventually produced the First Intermediate Period, a time of political division and social upheaval in which the centralized authority of the pharaoh was challenged by the provincial governors who had accumulated power during the later Old Kingdom. The collapse of the Old Kingdom was devastating for the pyramid building tradition, because the tradition depended on exactly the kind of centralized authority, concentrated resources, and institutional continuity that the collapse destroyed. The pyramid building program required the mobilization of thousands of workers, the management of supply chains extending across the length of Egypt, and the coordination of dozens of parallel construction activities over periods of decades. The program required a centralized state that could command these resources, and when the state fragmented, the resources fragmented with it, and the program ground to a halt. The halt was not merely a pause. It was a rupture, a break in the chain of institutional knowledge that had sustained the building tradition since the time of Imhotep and the Step Pyramid. The knowledge of how to build pyramids was held primarily in the minds of the builders. In the practical, experiential, embodied knowledge of the quarrymen, the masons, the surveyors, and the administrators who had learned their skills through the apprenticeship system and who transmitted their knowledge to the next generation through hands-on training and direct supervision. When the building program stopped, the apprenticeship system stopped with it. The experienced builders retired or died without training replacements, the institutional structures that supported the training were disbanded, and the practical knowledge that had been accumulated over centuries was gradually attenuated until it was effectively lost. The Middle Kingdom, the period that produced the Black Pyramid, began around 2050 BC, roughly a century after the collapse of the Old Kingdom. The Middle Kingdom pharaohs reunified Egypt, restored the centralized authority of the state, and revived the pyramid-building tradition. But the tradition they revived was not the tradition that had built the Great Pyramid. The knowledge had changed, the resources had changed, the techniques had changed. The Middle Kingdom builders were working with a diminished inheritance, a tradition that preserved the form of the pyramid, but that had lost the substance, the specific engineering knowledge that had made the Old Kingdom pyramids the most impressive stone structures in the ancient world. The most visible sign of the diminished inheritance was the shift from stone to mudbrick. The Old Kingdom pyramids, from the Step Pyramid through the Great Pyramid, were built primarily of cut limestone blocks, with stone cores and stone casing that were structurally integrated into a unified whole. The Middle Kingdom pyramids, including the Black Pyramid, were built primarily of mud brick, with cores of sun-dried mud brick blocks that were covered with a thin casing of limestone. The shift was fundamental. It transformed the pyramid from a massive stone structure that was inherently durable and structurally sound into a mud brick structure that was inherently fragile and structurally vulnerable. The limestone casing provided the appearance of a stone pyramid, but beneath the casing, the structure was mud brick, and mud brick does not endure the way stone does. The shift from stone to mud brick was not a deliberate choice. It was a consequence of the loss of institutional knowledge. The Middle Kingdom builders no longer possessed the specific knowledge of stone quarrying, stone transport, and stone placement at monumental scale that the Old Kingdom builders had developed over centuries of practice. The knowledge had been lost, attenuated during the generations when the building program was suspended, diluted by the institutional changes that the first intermediate period had produced, and finally forgotten as the last generation of builders who had learned the Old Kingdom techniques passed away without transmitting their knowledge to successors. The Middle Kingdom builders did not choose mud brick because they preferred it. They used mud bricks because they no longer knew how to build in stone at the scale that pyramid construction required. The first intermediate period, the era of political division and social upheaval that separated the Old Kingdom from the Middle Kingdom, was the critical interval during which the pyramid building knowledge was lost. The period lasted roughly a century and a half, from approximately 2150 BC to approximately 2050 BC, and during that time, the centralized institutions that had supported the pyramid building program were either dismantled or dramatically reduced. The provincial governors who had served the pharaoh during the Old Kingdom became independent rulers in their own right, controlling their own territories, commanding their own armies, and diverting the resources that had previously flowed to the central government into their own building programs and their own administrations. The result was a fragmentation of authority, resources, and institutional capacity that made large-scale construction projects impossible and that interrupted the chain of apprenticeship and training that had sustained the building tradition. The interruption was devastating because the knowledge of pyramid construction was experiential rather than theoretical. It was held in the minds and the hands of the builders rather than in written documents or formal treatises. The Egyptians were not a civilization of technical manuals. They did not produce the kind of written engineering documentation that would have allowed the knowledge to survive the death of the people who held it. The knowledge was transmitted through apprenticeship, through the direct, hands-on training of young workers by experienced masters, through the observation of techniques, through the practice of skills, and through the gradual accumulation of the practical understanding that comes only from years of doing the work. When the apprenticeship chain was broken, when the experienced masters retired or died without training replacements, the knowledge they carried died with them, and the next generation was left to start over with whatever fragments of the tradition they could piece together from the physical evidence of the Old Kingdom monuments. The physical evidence was impressive. The Old Kingdom pyramids were still standing, still visible, still available for study and emulation. But the physical evidence was also misleading, because the pyramids showed the results of the knowledge without revealing the knowledge itself. A builder who looked at the Great Pyramid could see that it was built of stone, that it was aligned to the cardinal points, that it had smooth sides and a sharp apex. But the builder could not see how the stone was quarried, how the blocks were transported, how the courses were laid, how the alignment was maintained, how the internal chambers were constructed, how the casing was finished, or how the quality was controlled. The visible form of the pyramid was the product of a vast body of invisible knowledge, and the loss of the invisible knowledge could not be compensated by the preservation of the visible form. The Middle Kingdom pharaohs who revived the pyramid building tradition were working from the visible form, trying to reproduce the appearance of the Old Kingdom pyramids without the invisible knowledge that had made the appearance possible. The attempt was brave. The attempt was also doomed, because the appearance without the knowledge produced structures that looked like pyramids from the outside, but that were structurally different in every respect that mattered. The difference was the mud brick, the weak, moisture-sensitive, structurally inadequate material that the Middle Kingdom builders substituted for the solid limestone that the Old Kingdom builders had used. The substitution was not a choice. It was a necessity, a consequence of the knowledge loss that left the Middle Kingdom builders without the capability to quarry, transport, and place stone at the scale that pyramid construction required. The 12th dynasty, the dynasty to which Amenemhat III belonged, was the most powerful and the most successful dynasty of the Middle Kingdom. The dynasty had reunified Egypt, restored the centralized authority of the pharaoh, and created a period of stability and prosperity that was remembered by later generations as one of the high points of Egyptian civilization. The pharaohs of the 12th dynasty were capable rulers. They managed the economy effectively. They maintained diplomatic relationships with neighboring states. They promoted art and literature, and they invested in monumental construction on a scale that was impressive by Middle Kingdom standards, even if it fell far short of the Old Kingdom achievements. Amenemhat III was the most prolific builder of the 12th dynasty. His building program included not only the Black Pyramid and the Hawara Pyramid, but also temples, fortifications, and the famous labyrinth at Hawara that the Greek historian Herodotus is described as more impressive than the pyramids themselves. The labyrinth was a vast complex of rooms, corridors, and courtyards that served as both a mortuary temple and an administrative center, a structure that demonstrated the Middle Kingdom builders' skill in the design of complex architectural spaces, even as their pyramid construction demonstrated their inability to replicate the structural achievements of the Old Kingdom. Amenemhat III, the pharaoh who built the Black Pyramid, was one of the most powerful and most capable rulers of the Middle Kingdom. He reigned for approximately 46 years, one of the longest reigns in Egyptian history, and his reign was marked by significant achievements in agriculture, administration, and foreign policy. He developed the Fayum region, the large, fertile depression west of the Nile Valley, into one of the most productive agricultural areas in Egypt, creating irrigation systems that increased the cultivable land and that generated the economic surplus that funded his building program. He was a capable administrator who maintained the stability and the prosperity of the state throughout his long reign. And he was a builder, a pharaoh who invested heavily in monumental construction, including 2 pyramids, multiple temples, and the famous labyrinth at Hawara that ancient writers regarded as one of the wonders of the world. The scale of the economic transformation between the Old Kingdom and the Middle Kingdom can be measured by the building programs each period produced. The Great Pyramid contained approximately 2.6 million cubic meters of stone, quarried, transported, and placed by a workforce of 20 to 30,000. The Black Pyramid contained a much smaller volume of mudbrick, requiring a smaller and less specialized workforce. The reduction reflected reduced resources. The Middle Kingdom state did not command the same proportion of national economic output that the Old Kingdom state had commanded. The administrative changes also affected the building program. The Old Kingdom administration was highly centralized. The pharaoh controlled all resources. The Middle Kingdom was more decentralized. Provincial governors retained autonomy, temples controlled resources independently, and pyramid construction competed with other claims on the state's wealth. The constraints contributed to the decision to build in mudbrick rather than stone, since mudbrick required a smaller workforce, shorter supply chains, and less demanding administration. The technological dimension of the knowledge loss was not merely a loss of skill, but of the entire system supporting the Old Kingdom program. Copper smelting and tool making, rope making, boat building for river transport, food production for the workforce, and administrative record keeping. Each element depended on the others, and the loss of any one compromised the whole. The Middle Kingdom builders inherited fragments of the system, but the fragments were insufficient to reconstitute the whole, and gaps were filled with inferior substitutes. The training system that had sustained the Old Kingdom building tradition, the apprenticeship system through which young workers learned stone quarrying, stone cutting, surveying, and masonry under the direct supervision of experienced masters, was the element most vulnerable to interruption, and its disruption during the first intermediate period was the primary mechanism through which the knowledge was lost. The apprenticeship system required continuity. Each generation of builders needed to train the next generation while the construction work was actually in progress, because the knowledge was practical and could only be transmitted through hands-on practice. When the construction stopped, the training stopped, and when the training stopped, the knowledge began to erode. Gradually at first, as the experienced masters aged and retired, and then more rapidly as the masters died without having trained replacements, and the knowledge they carried was lost forever. The Middle Kingdom builders who attempted to revive the pyramid building tradition were working with whatever fragments of the Old Kingdom knowledge they could reconstruct from the physical evidence of the surviving monuments, from the oral traditions that had been preserved in the scribal schools, and from the limited written records that described the construction process in general terms, without providing the specific, practical, step-by-step instructions that would have been needed to replicate the Old Kingdom techniques. The fragments were insufficient. They provided a general idea of what the Old Kingdom builders had done, but not the specific knowledge of how they had done it, and the gap between the general idea and the specific knowledge was the gap that the Black Pyramid's failure would reveal. The scale of the economic transformation between the Old Kingdom and the Middle Kingdom can be measured by comparing the building programs. The Great Pyramid contained approximately 2.6 million cubic meters of stone placed by 20 to 30,000 workers. The Black Pyramid contained a much smaller volume of mudbrick, requiring a smaller, less specialized workforce. The reductions reflected reduced resources. The Middle Kingdom state did not command the same proportion of national output as the Old Kingdom. The administrative decentralization of the Middle Kingdom also constrained the building program. Provincial governors retained autonomy, temples controlled resources independently, and pyramid construction competed with other claims on state wealth. These constraints contributed to the use of mudbrick rather than stone, since mudbrick required smaller workforces, shorter supply chains, and less demanding administration. The technological knowledge loss was not merely a loss of skill, but of the entire supporting system: copper smelting for tool making, rope making for hauling equipment, boat building for river transport, food production for the workforce, and administrative record keeping. Each element depended on the others, and the loss of any one compromised the whole. The Middle Kingdom inherited fragments insufficient to reconstitute the complete system. The training system, the apprenticeship, through which young workers learned stone quarrying, stone cutting, surveying, and masonry under experienced masters, was most vulnerable to interruption. It required continuity, each generation training the next while construction was in progress, because knowledge was practical and could only be transmitted through hands-on practice. When construction stopped during the first intermediate period, training stopped, and when training stopped, the knowledge began eroding, gradually as masters aged and retired, then rapidly as masters died without replacements. The Middle Kingdom builders attempting to revive the tradition worked from whatever fragments they could reconstruct. From the physical evidence of surviving monuments, oral traditions preserved in scribal schools, and limited written records describing the process in general terms without the specific step-by-step instructions needed to replicate Old Kingdom techniques. The fragments provided a general idea of what the Old Kingdom builders had done, but not the specific knowledge of how. And the gap between the general idea and the specific knowledge was the gap the Black Pyramid's failure would reveal. The physical characteristics of the Djoser Plateau, its limestone bedrock, its proximity to the Nile, its elevation above the floodplain, had made it an attractive site for pyramid construction since Sneferu's time. The Middle Kingdom builders chose Djoser for the same reasons that the Old Kingdom builders had chosen it: the geological suitability of the site, the logistical convenience of the location, and the prestige of building near the great Old Kingdom monuments that already stood on the plateau. The choice was both practical and symbolic. The proximity to the Red Pyramid and the Bent Pyramid connected the Middle Kingdom pharaoh to the tradition of his Old Kingdom predecessors, and proclaimed his claim to be their legitimate successor. The irony of the choice was that the Djoser Plateau presented challenges that the Middle Kingdom builders were less well equipped to handle than their Old Kingdom predecessors had been. The groundwater conditions at Djoser, the high water table, the seasonal fluctuations in the water level, the potential for moisture infiltration into subterranean structures, were conditions that the Old Kingdom builders had managed successfully through their knowledge of foundation preparation and their use of materials that were resistant to moisture. The Middle Kingdom builders, working with moisture-vulnerable mud brick and without the full knowledge of foundation preparation that the Old Kingdom builders had possessed, were less capable of managing these conditions, and the consequences of their reduced capability would be visible in the structural problems that the Black Pyramid experienced. The relationship between the Old Kingdom building tradition and the Middle Kingdom revival can be understood through the analogy of a language that was once spoken fluently by a community of practitioners, but that fell into disuse during a period of interruption, and that was then revived by a later generation who knew the vocabulary but had lost the grammar, who could recognize the words but could no longer construct the sentences, who could identify the components but could no longer assemble them into a functioning whole. The Middle Kingdom builders knew the vocabulary of pyramid construction. They knew what a pyramid looked like, they knew what materials were used, and they knew the general sequence of the construction process. But they had lost the grammar, the specific, practical knowledge of how the materials were selected, how the blocks were quarried and shaped, how the courses were laid and leveled, how the alignment was maintained, and how the quality was controlled throughout the construction process. The vocabulary without the grammar produced the Black Pyramid, a structure that used the right words in the wrong order, that had the right components assembled in the wrong way, and that failed because the gap between knowing what to build and knowing how to build it was too great to bridge with vocabulary alone. The Middle Kingdom pharaohs' awareness of the gap between their capability and their ancestors' achievements is suggested by several features of their building programs that can be interpreted as compensatory, as attempts to offset the diminished quality of their pyramids with achievements in other domains. The most notable compensatory achievement was the elaboration of the mortuary temple, the ritual complex that surrounded the pyramid and that served the religious functions of the pharaoh's funerary cult. The Middle Kingdom mortuary temples were larger, more complex, and more elaborately decorated than their Old Kingdom counterparts, a development that may have been driven partly by the desire to create impressive monuments in a domain where the builder's capability was not as severely diminished as it was in the domain of pyramid construction. The relationship between the Old Kingdom building tradition and the Middle Kingdom revival can be understood through the analogy of a language once spoken fluently, but that fell into disuse and was then revived by a later generation who knew the vocabulary but had lost the grammar. The Middle Kingdom builders knew the vocabulary of pyramid construction. What a pyramid looked like, what materials were used, the general construction sequence, but they had lost the grammar, the specific practical knowledge of how materials were selected, how blocks were quarried, how courses were laid, how alignment was maintained, how quality was controlled. The vocabulary without the grammar produced the Black Pyramid, a structure that used the right words in the wrong order. The Middle Kingdom pharaohs' awareness of the gap between their capability and their ancestors' achievements is suggested by compensatory features, attempts to offset diminished pyramid quality with achievements in other domains. The mortuary temples were larger, more complex, and more elaborately decorated than Old Kingdom counterparts, a development driven partly by the desire to create impressive monuments in domains where the builder's capability was not as severely diminished. The labyrinth at Hawara was the supreme expression of this compensatory impulse, a monument that exceeded Old Kingdom achievements in temple complexity, even as it fell short in pyramid construction. The specific mechanisms through which the knowledge was lost deserve enumerations, because they illuminate the vulnerability of institutional knowledge in any civilization. The first mechanism was the interruption of the apprenticeship chain during the first intermediate period. When construction stopped, training stopped, and when training stopped, the experiential knowledge began to erode. The second mechanism was the institutional fragmentation. When the centralized state dissolved into competing provincial governments, the unified workforce was dispersed and the organizational knowledge was scattered. The third mechanism was the passage of time. The roughly 150 years of the first intermediate period was long enough for 3 to 4 generations of builders to pass without transmitting their knowledge, creating a gap that could not be bridged by the builders who came after. The fourth mechanism was the change in priorities. When the Middle Kingdom state was reconstituted, the resources that had been devoted to pyramid construction in the Old Kingdom were partially redirected to other purposes, reducing the scale of the building program and the institutional capacity that the program could sustain. The construction timeline of the Black Pyramid. The number of years that the construction required before the project was abandoned is not precisely known, but estimates based on the volume of material and the assumed pace of constructions suggest that the project was underway for at least a decade, and possibly longer, before the structural problems forced its abandonment. The duration of the project means that the economic investment was substantial. A decade or more of sustained effort by a workforce of hundreds or thousands of workers, consuming materials, tools, food, and administrative resources that represented a significant share of the state's available output. The loss of this investment when the project was abandoned was one of the most significant economic setbacks of Amenemhat III's reign, a setback that was compounded by the need to invest additional resources in the construction of the replacement pyramid at Hawara. The comparison between the construction timelines of the Old Kingdom and Middle Kingdom pyramids reveals another dimension of the knowledge loss. The Great Pyramid was built in approximately 20 years, a pace that required the placement of roughly 340 blocks per day, every day, for 2 decades. The pace was achievable because the Old Kingdom builders had developed efficient quarrying, transport, and placement techniques that allowed them to move and place stone at rates that the Middle Kingdom builders could not match. The Middle Kingdom builders, working with mudbrick rather than stone, could manufacture and place bricks at rates that were comparable to or faster than the Old Kingdom stone placement rates. But the bricks they placed were structurally inferior, and the speed of their placement could not compensate for the fundamental weakness of the material. The role of the Nile flood cycle in the construction process was as important for the Black Pyramid as it had been for the Old Kingdom pyramids, though the relationship between the flood and the construction was different because the Black Pyramid's mudbrick core was manufactured from Nile mud rather than quarried from limestone bedrock. The mudbrick manufacturing process required large quantities of Nile alluvium, the rich, dark mud that was deposited on the floodplain during each annual inundation, and that provided the raw material for brick production. The manufacturing was seasonal, concentrated in the months immediately after the flood receded, when the fresh mud was available and when the agricultural labor force was not yet needed in the fields. The seasonal rhythm of brick production created a construction cycle that was different from the year-round construction cycle of the Old Kingdom stone pyramids, a cycle in which the production of building material was concentrated in one season and the construction itself extended throughout the year as the accumulated bricks were placed in the growing structure. But Amenemhat III was not Khufu. He did not command the resources, the knowledge, or the institutional capacity that Khufu had commanded 8 centuries earlier. His building program was ambitious, but the ambition was constrained by the limitations of the diminished tradition that he had inherited, and the constraints were visible in the materials, the methods, and the structural performance of the monuments he produced. The Black Pyramid was the most dramatic expression of these constraints, a pyramid that was conceived with the ambition of the Old Kingdom, but that was executed with the techniques of the Middle Kingdom, and that failed. because the gap between the ambition and the techniques was too great to be bridged. The core problem of the Black Pyramid is structural, a fundamental incompatibility between the form of the pyramid, which demands structural stability under enormous compressive loads, and the material from which it was built, mudbrick, which is inherently weak, moisture-sensitive, and incapable of sustaining the loads that a pyramidal structure imposes. The incompatibility produced structural problems that the builders could not solve, problems that worsened as the construction progressed, that threatened the stability of the entire structure, and that ultimately forced Amenemhat III to abandon the Black Pyramid and to build a second pyramid at Hawara, roughly 40 kilometers to the south, as an alternative burial place. The structural problems began with the foundation. The Black Pyramid was built on the Djoser Plateau, the same plateau that supported the Bent Pyramid and the Red Pyramid, the same plateau whose geological characteristics had been assessed and exploited by Sneferu's builders 8 centuries earlier. But the Black Pyramid's builders did not prepare the foundation with the same thoroughness that Sneferu's builders had applied. They did not level the bedrock with the same precision. They did not remove the weak layers with the same care, and they did not assess the load-bearing capacity of the rock with the same rigor. The inadequate foundation preparation was a consequence of the knowledge loss, the specific knowledge of how to prepare a foundation for a monumental stone structure was part of the practical tradition that had been attenuated during the centuries of interrupted construction. The structural problems were compounded by the choice of material. Mudbrick is a weak material, weaker than limestone by several orders of magnitude in compressive strength and catastrophically vulnerable to moisture. Limestone blocks can bear enormous compressive loads without deformation. They can support the weight of a pyramid 146 meters tall, without cracking, without crushing, and without significant settlement. Mudbrick cannot. It deforms under heavy loads, it cracks under differential stress, and it dissolves when exposed to water. The choice of mudbrick for the core of the Black Pyramid meant that the structure was, from the beginning, operating at the limits of its material capacity, limits that were far lower than the limits that a stone core would have provided and that were eventually exceeded by the loads that the construction imposed. The specific engineering challenges that the groundwater posed for the substructure deserve detailed examination. The substructure was designed to be dry, a sealed environment protecting the burial from moisture and biological agents. The design assumed impermeable bedrock, but the limestone at Djoser contains fractures and permeable zones through which groundwater moves slowly but persistently. The cumulative effect of continuous infiltration over decades was the saturation of spaces intended to remain dry, dissolving mortar, weakening bedrock, corroding metal fittings, and making organic preservation impossible. The builders may have been aware of the problem before construction was complete. Repairs and reinforcements suggest they were responding to observed water infiltration. This awareness would have added urgency to the abandonment decision, recognizing that the substructure was not merely structurally but hydrologically compromised, unable to protect a burial from moisture. The burial chamber was lined with quartzite, a particularly hard, moisture-resistant stone chosen for its durability and aesthetic quality. The quartzite lining demonstrates awareness of the moisture threat, selecting a material more resistant than the limestone lining of the passages. The precaution was sensible but insufficient. Quartzite could protect against direct contact with wet bedrock, but could not prevent moisture infiltrations through air and capillary action. The contrast between the substructure's design sophistication and its environmental vulnerability is one of the most poignant aspects of the story. The builders designed a labyrinthine passage system of extraordinary ingenuity. One of the most complex underground constructions in Egyptian architecture, sophisticated enough to deter any human intruder. But the design failed against a different intruder. Groundwater that rose from below, infiltrated through bedrock, and saturated the spaces designed to be sealed. The human intruder was defeated. The natural intruder was not. The structural analysis of the mudbrick core under combined stresses of gravity and moisture has revealed that mudbrick loses 70 to 80% of its compressive strength when saturated. The implication is devastating. The rising groundwater reduced the load-bearing capacity of the base to a fraction of its dry value, creating conditions where the weight exceeded the base's capacity, producing the cracking, settlement, and deformation observed during construction. The builder's response was limited by the nature of the problem. Groundwater could not be stopped, the mud brick core could not be replaced, and moisture damage could not be repaired. They could reinforce passages with timber and masonry, and may have attempted drainage, but the fundamental incompatibility between mud brick and moisture could not be solved within the constraints of existing design and knowledge. The only solution was abandonment. The decision to abandon represented the culmination of a slow-developing crisis rather than a response to a sudden catastrophe. The crisis developed over years, gradually worsening as groundwater rose, as the mud brick core absorbed more moisture, as the compressive capacity of the lower courses diminished, and as the structural distress became progressively more severe and more visible. The builders monitored the situation, attempted repairs, and evaluated the prospects for completion before finally concluding that the pyramid could not serve its intended purpose. The decision was painful. It represented the loss of years of labor and millions of mud bricks. But it was correct, and the correctness of the decision is confirmed by the subsequent deterioration of the pyramid, which has continued for nearly 4,000 years and which shows no sign of stopping. Something is wrong with our assumptions when we treat the Middle Kingdom pyramids as simple continuations of the Old Kingdom tradition, as if the Middle Kingdom builders were doing the same thing that the Old Kingdom builders had done, only on a smaller scale. The Middle Kingdom builders were not doing the same thing. They were doing something fundamentally different. Building in mud brick rather than in stone, covering the mud brick core with a thin veneer of limestone that created the appearance of a stone pyramid without the structural substance, and hoping that the veneer would be sufficient to maintain the form while the mud brick core maintained the mass. The hope was misplaced. Because the veneer was not structural, the mud brick core was not adequate, and the combination of the two produced a structure that was doomed to fail. The relationship between the Black Pyramid's superstructure and its substructure, between the mud brick mass above and the stone-cut passages below, illuminates a fundamental asymmetry in the Middle Kingdom building tradition that has implications far beyond the specific case of the Black Pyramid. The superstructure was built of the weakest material in the builder's repertoire, mud brick, the material of domestic construction, the material of temporary buildings, the material that every Egyptian knew would not endure. The substructure was built of the strongest material available, cut stone, carefully fitted and precisely finished, demonstrating a level of craftsmanship that was comparable to the best work of the Old Kingdom builders. The asymmetry between the weak superstructure and the strong substructure reflects the selective character of the knowledge loss, the loss of the capability for large-scale stone construction, while the capability for smaller-scale stonework was retained. The asymmetry also reflects a practical calculation. The substructure was the element that mattered most, the element that directly protected the pharaoh's burial, and the builders allocated their strongest material and their most skilled craftsmanship to the element that mattered most. The superstructure was, in a sense, expendable. Its primary function was to create the visible form of the pyramid, the external appearance that proclaimed the pharaoh's status and his connection to the divine tradition. The superstructure could be built of mud brick without compromising the protection of the burial, provided that the limestone casing held and provided that the environmental conditions were favorable. The calculation was rational, but it was also a compromise, an acknowledgement that the builders could not achieve the Old Kingdom standard in all domains, and that they needed to concentrate their limited resources on the elements that mattered most. The engineering of the portcullis system, the massive stone blocks that were designed to seal the passages after the pharaoh's burial, represents one of the most technically sophisticated elements of the Black Pyramid substructure and provides evidence for the Middle Kingdom builders' capability in precision stone fitting. The portcullises were quartzite blocks, cut to precise dimensions, finished to smooth surfaces, and designed to slide along grooves cut into the walls of the passages, with tolerances that were measured in millimeters rather than centimeters. The precision of the portcullis work demonstrates that the Middle Kingdom builders were capable of the kind of tight tolerance, stone fitting, that the Old Kingdom builders had used for the casing of their pyramids. The capability was retained for small-scale applications, even though it had been lost for large-scale ones. The portcullis mechanism itself was ingenious. The blocks were held in raised positions during the construction by temporary props, and the removal of the props after the burial would allow the blocks to drop into their final positions under the influence of gravity, sealing the passages permanently. The mechanism required careful engineering. The grooves had to be precisely aligned, the blocks had to be precisely dimensioned, and the props had to be strong enough to hold the blocks in position during the construction, but removable enough to be extracted by the burial party after the interment was complete. The engineering was sound. The mechanism worked as designed, and the portcullises are still in their final positions today, nearly 4,000 years after they were lowered into place. The passage layout of the Black Pyramid was designed as a three-dimensional puzzle, a spatial labyrinth that required the navigator to move not only horizontally but also vertically, ascending and descending through multiple levels, turning corners, traversing blind alleys, and passing through concealed openings that were invisible to anyone who did not know the exact location and the exact method of access. The three-dimensional character of the labyrinth was itself an innovation. Earlier anti-robbery systems had been primarily two-dimensional, with passages and chambers arranged on a single level. The Black Pyramid system operated on multiple levels, creating a spatial complexity that was far more difficult to navigate than a single-level system, and that required the robber to think in 3 dimensions rather than 2. And it gets worse, because the most impressive feature of the Black Pyramid is not its superstructure, it is its substructure, the elaborate underground passage system that was carved into the bedrock beneath the pyramid, and that represents one of the most complex and most ingenious subterranean constructions in all of Egyptian architecture. The substructure includes a labyrinthine system of passages, dead ends, portcullises, and blind corridors that were designed to confuse and to frustrate tomb robbers who might attempt to reach the burial chamber. The system is sophisticated. It demonstrates that the Middle Kingdom builders retained significant engineering skill in the design of subterranean structures, even as they had lost the knowledge needed to build structurally sound superstructures. The sophistication of the substructure makes the failure of the superstructure all the more poignant. It demonstrates that the builders were capable of impressive engineering feats, but that their capabilities were not equally distributed across all domains of pyramid construction. The groundwater problem at the Black Pyramid deserves extended discussion because it illustrates one of the most insidious forms of structural failure, the failure that is caused not by a single dramatic event but by a slow, continuous cumulative process that operates below the surface and that produces visible effects only after the damage has become irreversible. The groundwater at Djoser is not static. It rises and falls with the seasons, with the flooding of the Nile, and with the long-term changes in the hydrological regime of the Nile Valley. The rising water table infiltrated the subterranean passages and chambers of the Black Pyramid through the porous limestone bedrock, seeping through the rock, filling the spaces, saturating the stone, and creating conditions of perpetual moisture that were incompatible with the preservation of the burial and the structural integrity of the substructure. The moisture affected the mudbrick superstructure as well, rising through the base of the pyramid by capillary action, saturating the lower courses of mudbrick, weakening the bonds between the bricks, and creating conditions that promoted the deterioration of the core from the bottom up. The deterioration was gradual. It proceeded over years and decades, rather than over days or weeks. But it was relentless, and its effects were cumulative. Each season brought more moisture, more saturation, more weakening, more deterioration, and the cumulative effect, over centuries, was the gradual dissolution of the mud brick core that has produced the eroded mound that visitors see today. The decision to abandon the Black Pyramid was not made lightly. It was the result of a careful assessment of the structural damage, the prospects for repair, and the costs of continuing the construction versus the costs of starting over at a new site. The decision-making process has not been documented in any surviving text. The ancient Egyptians did not leave written records of their engineering deliberations, but the archaeological evidence suggests that the decision was made relatively late in the construction process, after the superstructure had risen to a significant height and after the substructure had been substantially completed. The timing of the decision suggests that the builders tried to save the project, that they attempted to address the structural problems through repairs and reinforcements, before concluding that the problems were too severe to be overcome. The measures that the builders took to address the structural problems, the timber reinforcements in the passages, the additional masonry in the weakened areas, the possible attempts at drainage, represent a phase of the construction that is sometimes overlooked in the narrative of the Black Pyramid's failure. The phase is important because it demonstrates that the builders did not give up easily. They fought to save the project, investing additional labor and materials in the effort to stabilize the structure and to maintain its viability as a burial place. The effort was ultimately unsuccessful. The structural problems were too fundamental, too deeply rooted in the choice of materials and the conditions of the site to be overcome by the kind of repairs that the builders could implement. But the effort was real, and it deserves to be recognized as evidence of the builder's skill and determination, qualities that the narrative of failure tends to obscure. The choice of Hawara as the site for the replacement pyramid was itself significant. It reflected the builder's recognition that the groundwater conditions at Djoser were a contributing factor in the Black Pyramid's failure, and that the new site needed to offer better conditions for the preservation of the subterranean burial. The Hawara site, located at the entrance to the Fayum Depression, roughly 40 kilometers south of Djoser, offered a different geological and hydrological environment that the builders hoped would be more favorable for the preservation of the burial. The hope was partially fulfilled. The Hawara pyramid was completed and was used for the pharaoh's burial, and the burial survived for a longer period than it would have at the Black Pyramid. But the Hawara site had its own problems, and the Hawara pyramid, like the Black Pyramid, has deteriorated significantly over the millennia. The relationship between the Black Pyramid and the Hawara pyramid, between the failed first attempt and the somewhat more successful second attempt, echoes, in a diminished key, the relationship between the Bent Pyramid and the Red Pyramid 8 centuries earlier. In both cases, a pharaoh built a pyramid that encountered structural problems, and in both cases, the pharaoh responded by building a second pyramid that incorporated the lessons of the first. But the parallels are limited. The Bent Pyramid's problems were problems of design that could be solved by changing the design, while the Black Pyramid's problems were problems of material that could not be solved without changing the material. The Bent Pyramid's successor, the Red Pyramid, was a triumph, a structure that solved the problems and that established the template for all subsequent pyramid construction. The Black Pyramid's successor, the Hawara Pyramid, was a compromise, a structure that mitigated the worst of the problems, but that could not overcome the fundamental limitation of the mud brick material. The irony of the groundwater problem, the fact that the rising water table was partly a consequence of the irrigation projects that Amenemhat III himself had promoted, adds a dimension of tragic paradox to the Black Pyramid story. Amenemhat III was one of the most effective agricultural administrators in Egyptian history. His development of the Fayum region created new farmland, increased agricultural production, and generated the economic surplus that funded his ambitious building program. But the irrigation systems that made the Fayum productive also raised the water table in the surrounding region, including the Djoser Plateau, where the rising water infiltrated the substructure of the Black Pyramid and contributed to the structural problems that forced the pharaoh to abandon the pyramid and build a replacement at Hawara. The pharaoh's greatest economic achievement undermined his greatest architectural achievement, a connection that the pharaoh himself may or may not have recognized, but that modern analysis has confirmed. The decision to abandon the Black Pyramid was not made lightly. It was the result of careful assessment of the structural damage, the prospects for repair, and the costs of continuing versus starting over at a new site. The archaeological evidence suggests the decision was made relatively late in construction, after the superstructure had risen significantly and the substructure was substantially complete. The timing suggests the builders tried to save the project, attempting repairs and reinforcements before concluding the problems were too severe. The measures taken to address the structural problems, timber reinforcements, additional masonry, possible drainage attempts, represent a phase sometimes overlooked in the failure narrative. The phase demonstrates that the builders did not give up easily. They fought to save the project, investing additional labor and materials. The effort was ultimately unsuccessful. The problems were too fundamental, too rooted in material choice and site conditions, but it was real and deserves recognition as evidence of the builder's skill and determination. The relationship between the Black Pyramid and the Hawara Pyramid echoes the Bent Pyramid, Red Pyramid relationship 8 centuries earlier. In both cases, a pharaoh built a pyramid with structural problems and responded by building a second pyramid incorporating lessons from the first. But the parallels are limited. The Bent Pyramid's problems were design problems solvable by design changes, while the Black Pyramid's problems were material problems unsolvable without changing the material. The Bent Pyramid's successor was a triumph. The Black Pyramid's successor was a compromise that mitigated the worst problems but could not overcome the fundamental mudbrick limitation. The progressive failure sequence can be reconstructed from the archaeological evidence. Failure began with the foundation, settlement, and deformation under the growing structure's weight. It continued with the core, cracking and deformation of the mudbrick mass under compressive loads. It was accelerated by groundwater. Rising water that saturated lower courses, reduced their strength, and created conditions where the weight exceeded the base's capacity. And it culminated in abandonment, the recognition that damage was too severe to repair. The compressive strength of mudbrick, roughly 1 to 2 megapascals, compared to limestone's 20 to 60 megapascals, reveals the fundamental material limitation. Limestone is 20 to 50 times stronger in compression, meaning a limestone pyramid can sustain vastly greater loads. The Black Pyramid's 75-meter height and approximately 57-degree angle represented the approximate maximum for mudbrick, and even this proved beyond actual capacity when groundwater reduced the saturated lower course's strength to a fraction of their dry value. The limestone casing that covered the core served 2 functions: protecting the core from elements and creating the visual appearance of a stone pyramid. It partially served the first, but could not prevent rising groundwater from below. It completely served the second. From outside, the Black Pyramid would have looked like a stone pyramid, indistinguishable from Old Kingdom monuments. But the appearance was deceptive, concealing a structurally incomparable mudbrick interior. The structural behavior of the mudbrick core under the combined stresses of gravity and moisture infiltration has been studied by engineers who have analyzed the properties of mudbrick under various conditions of load and moisture. The analysis has revealed that mudbrick is dramatically weakened by moisture. Its compressive strength drops by as much as 70 to 80% when the brick is saturated, meaning that a mudbrick wall that can support a given load when dry will collapse under the same load when wet. The implication for the Black Pyramid is clear. The rising groundwater, by saturating the lower courses of the mudbrick core, reduced the load-bearing capacity of the base to a fraction of its dry weather value, creating conditions under which the weight of the overlying structure exceeded the capacity of the base to support it, and producing the cracking, the settlement, and the deformation that the builders observed during the construction. The builders' response to the structural problems was limited by the nature of the problem. The groundwater infiltration could not be stopped, the mudbrick core could not be replaced with stone, and the structural damage that the moisture had caused could not be repaired. The builders could reinforce the passages, and they did, inserting timber supports and additional masonry to shore up the weakened areas. The builders could attempt to divert the groundwater, and they may have tried, though the evidence for drainage systems at the Black Pyramid is uncertain. But the fundamental problem, the incompatibility between the mud brick material and the moisture environment, could not be solved within the constraints of the existing design and the available knowledge. The only solution was abandonment, the decision to leave the Black Pyramid unfinished, and to build a new pyramid at a site where the groundwater conditions were more favorable. The three-dimensional labyrinth of the Black Pyramid's substructure required the navigator to move not only horizontally, but vertically, ascending and descending through multiple levels, turning corners, traversing blind alleys, and passing through concealed openings invisible to anyone without exact knowledge of their location and method of access. The three-dimensional character was itself an innovation. Earlier anti-robbery systems had been primarily two-dimensional with passages on a single level. The Black Pyramid operated on multiple levels, creating spatial complexity far more difficult to navigate and require three-dimensional rather than two-dimensional thinking. The engineering of the portcullis system represents one of the most technically sophisticated elements. The portcullises were quartzite blocks cut to precise dimensions, finished to smooth surfaces, designed to slide along grooves with millimeter tolerances. The precision demonstrates capability in tight tolerance stone fitting that the Old Kingdom had used for pyramid casing, retained for small-scale applications, even though lost for large-scale ones. The mechanism was ingenious. Blocks held in raised positions by temporary props, removable by the burial party, to allow the blocks to drop under gravity and permanently seal the passages. The engineering was sound. Portcullises remain in their final positions nearly 4,000 years later. The relationship between the superstructure and the substructure illuminates a fundamental asymmetry in the Middle Kingdom tradition. The superstructure used the weakest material, mudbrick, the material of temporary domestic buildings. The substructure used the strongest, cut stone, carefully fitted and precisely finished, demonstrating craftsmanship comparable to Old Kingdom work. The asymmetry reflects both selective knowledge loss and practical calculation. The substructure directly protected the burial and received the strongest material and most skilled craftsmanship, while the superstructure primarily created visible form and could be built of mud brick without compromising burial protection, provided the casing held and environmental conditions cooperated. The passage layout was designed as a spatial puzzle requiring movement through multiple levels with ascending and descending corridors, right-angle turns, concealed entrances behind removable stone panels, and dead-end passages designed to waste the time and exhaust the patience of any intruder. The designers anticipated that robbers would enter with limited light, limited tools, and limited time, and the labyrinth was designed to exploit all three limitations, creating conditions that would maximize the difficulty of finding the correct route and minimize the probability that any intruder would reach the burial chamber before being forced to abandon the attempt. The ventilation of the subterranean spaces during construction was itself an engineering challenge. The passages were deep, the air circulation was limited, and the workers who carved the passages and the chambers needed to breathe while they worked in confined spaces far below the surface. The builders addressed the ventilation challenge with shafts that connected the subterranean spaces to the surface, shafts that allowed fresh air to circulate through the passage system, and that removed the stale air and the stone dust that the quarrying process produced. The ventilation shafts were sealed after the construction was complete, eliminating the air circulation that had been provided during the construction and creating the sealed environment that the preservation of the burial required. The mud brick manufacturing process itself, while simpler than the stone quarrying process that the Old Kingdom builders had used, was a substantial industrial operation that required careful management and quality control. The bricks were made from Nile alluvium, the dark, fertile mud that was deposited on the floodplain during each annual inundation. The mud was mixed with water and with organic binders, straw, chaff, or other plant material that improved the cohesion of the mixture and that reduced the tendency of the bricks to crack during the drying process. The mixture was pressed into wooden molds of standardized dimensions, creating bricks of uniform size and shape that could be laid in regular courses, and that would produce a mass of consistent structural properties. The bricks were dried in the sun, a process that took several days and that required careful management to ensure that the bricks dried uniformly without cracking or warping. The quality of the bricks was critical to the structural performance of the pyramid, because the compressive strength of the entire mass depended on the compressive strength of the individual bricks, and defective bricks could create weak points in the structure that would concentrate stress and promote failure. The quality control process involved the inspection of each batch of bricks before they were placed in the structure, checking for cracks, for dimensional accuracy, for adequate drying, and for the overall consistency of the material. The quality control was thorough. The bricks that have been examined by modern analysts are generally of good quality, with consistent dimensions and adequate strength for their intended purpose. The overall quality of the individual bricks was definitively not the problem. The problem was the material itself, the fundamental inadequacy of even the best mud brick for the kind of permanent, monumental construction that the pyramid tradition demanded. The rate of brick production, the number of bricks that could be manufactured per day by a given workforce, was a critical factor in determining the pace of the construction and the total duration of the project. The rate depended on the number of brickmakers, the availability of raw materials, weather conditions that affected the drying time, and the organizational efficiency of the manufacturing operation. The rate was probably high. Mud brick manufacture is a relatively fast process compared to stone quarrying, and a well-organized workforce could produce thousands of bricks per day. The high production rate was one of the advantages of mud brick construction. It allowed the structure to rise relatively quickly, compensating partly for the material's structural weakness with the speed of the construction process. The environmental monitoring of the Black Pyramid site, conducted by conservation specialists who are concerned about the long-term preservation of the remaining structure, has revealed that the groundwater conditions at Djoser continue to pose a threat to the pyramid's survival. The water table fluctuates seasonally, rising during the flood period and falling during the dry season, and the fluctuations create cycles of wetting and drying that accelerate the deterioration of the mud brick core. Each cycle of wetting weakens the bricks, and each cycle of drying causes the weakened bricks to crack and to fragment, producing a progressive deterioration that has been reducing the pyramid's mass for centuries, and that will continue to reduce it for as long as the cycles continue. The monitoring data have confirmed that the rate of deterioration is significant, measurable in centimeters per decade, and that the pyramid's current condition represents a late stage in a process of decay that has been operating since the structure was first built. But here's what makes this truly terrifying. The substructure, the elaborate, ingenious, beautifully designed passage system, was defeated not by tomb robbers, but by groundwater. The water table at Djoser is high, higher than it was during the Old Kingdom, partly because of the irrigation projects that Amenemhat III himself had promoted in the nearby Fayoum region. The rising water table infiltrated the underground passages and chambers, flooding the spaces that were designed to protect the pharaoh's burial for eternity, and rendering the entire substructure unsuitable for its intended purpose. The pharaoh's own agricultural improvements, the irrigation systems that had made the Fayoum productive, and that had generated the economic surplus that funded the pyramid's construction, contributed to the rising water table that destroyed the pyramid's ability to serve as a tomb. The irony is devastating. The pharaoh's greatest achievement undermined his greatest monument. The Black Pyramid story illuminates a broader pattern in the history of civilizations, the pattern in which the achievements of one era are lost to the next. in which the knowledge that sustains great institutions is attenuated by the passage of time, and in which later generations, however talented and however ambitious, find themselves unable to replicate the achievements of their predecessors, because the specific knowledge that made those achievements possible is no longer available. The first exploration examines the superstructure of the Black Pyramid in detail. The mudbrick core, the limestone casing, and the structural problems that the combination of the two produced. The mudbrick core of the Black Pyramid was built using sun-dried bricks of Nile mud. Bricks that were manufactured at the construction site using mud from the nearby floodplain, mixed with straw or chaff to improve their cohesion, formed in wooden molds and dried in the sun until they were hard enough to be stacked and built into walls. The bricks were laid in courses, horizontal layers that extended across the entire footprint of the pyramid and that rose, course by course, from the base to the summit. The courses were bonded with mud mortar, the same material as the bricks themselves, applied between the courses to create a continuous mass that was intended to behave as a unified structure. The limestone casing was applied to the outside of the mudbrick core, a layer of cut limestone blocks that was designed to create the smooth, sloping surface of the finished pyramid and to protect the mudbrick core from the elements. The casing was the pyramid's armor, the barrier between the vulnerable mudbrick interior and the destructive forces of wind, rain, and sun that the desert environment imposed. The casing was essential. Without it, the mudbrick core would have been exposed to the elements and would have begun to erode immediately. With it, the core was protected, at least temporarily, from the forces that would eventually destroy it. The problem was that the casing was not structural. It was not designed to bear the loads that the pyramid imposed, and it was not capable of compensating for the structural weakness of the mudbrick core. The casing was a veneer, a thin layer of stone applied to the outside of a much larger structure of mudbrick, without the deep, interlocking connections that would have been needed to create a structurally integrated whole. The casing protected the core from the weather, but it could not protect the core from the forces of gravity, compression, and moisture infiltration that were acting on it from within. The second exploration examines the substructure of the Black Pyramid, the underground passage system that is one of the most complex and most ingenious subterranean constructions in all of Egyptian architecture. The substructure was carved into the bedrock beneath the pyramid, a labyrinthine system of passages, chambers, and corridors that extended for dozens of meters below the surface, and that was designed to protect the pharaoh's burial from the tomb robbers who had plundered the Old Kingdom pyramids in the centuries of political instability that followed the collapse of the Old Kingdom. The anti-robbery features included dead-end corridors that led nowhere, passages that appeared to lead to the burial chamber but that terminated in blank walls designed to frustrate robbers who were searching for the burial chamber in the darkness. The features included portcullises, massive stone blocks that were lowered into position to block the passages after the burial was complete, creating barriers that could not be moved without the application of enormous force. And the features included false floors and concealed openings, architectural deceptions that were designed to mislead robbers about the true layout of the passage system and to direct them away from the actual burial chamber. The ingenuity of the anti-robbery system reflects the Middle Kingdom builders' awareness of the vulnerability of pyramid burials, an awareness that was informed by the systematic plundering of the Old Kingdom pyramids during the First Intermediate Period. The Old Kingdom pyramids had relied primarily on mass, on the sheer weight and the volume of stone that surrounded the burial chamber, to protect the burial from disturbance. The strategy had failed. The tomb robbers had found ways to penetrate the stone, to bypass the blocking systems, and to reach the burial chambers despite the enormous mass of the pyramids. The Middle Kingdom builders responded with a different strategy: complexity rather than mass, deception rather than weight, a labyrinthine passage system that was designed to confuse the robbers rather than to overpower them. The third exploration examines the pyramidion, the capstone that crowned the apex of the Black Pyramid, and that is one of the most important surviving artifacts of the Middle Kingdom. The The pyramidion of the Black Pyramid has survived, a remarkable fact, given that the capstones of most Egyptian pyramids have been lost to theft, erosion, or simple gravity. The pyramidion is made of dark stone, basalt, or a similar material, and its dark color may have given the Black Pyramid its modern name. The pyramidion is now in the Egyptian Museum in Cairo, where it is one of the most important artifacts in the museum's Middle Kingdom collection. The pyramidion is inscribed. It bears hieroglyphic texts that include the name and titles of Amenemhat III and religious formulas that dedicate the pyramid to the gods and that invoke their protection for the pharaoh's eternal survival. The survival of the pyramidion is a poignant detail in the Black Pyramid's story, because the pyramidion was designed to crown a pyramid that was never used for its intended purpose. The capstone was placed at the summit of a structure that was already failing, a structure that would be abandoned before the pharaoh's burial, and that would eventually collapse into the eroded mound that visitors see today. The pyramidion survives. The pyramid does not. The contrast between the survival of the capstone and the collapse of the structure it was designed to crown is one of the most eloquent illustrations of the fragility of monumental construction, and of the irony that the smallest element of the pyramid has outlasted the pyramid itself by millennia. The fourth exploration examines the decision to abandon the Black Pyramid and to build a second pyramid at Hawara, a decision that reflects the severity of the structural problems and the pharaoh's recognition that the Black Pyramid could not serve as his tomb. The decision to abandon the Black Pyramid was one of the most consequential decisions in the history of Egyptian pyramid construction, because it was an admission of failure, an acknowledgement that the structure was not sound, that the design was not adequate, and that the pharaoh's eternal survival could not be entrusted to a building that was showing signs of structural distress while the construction was still in progress. The decision required Amenemhat III to invest additional resources in the construction of a new pyramid, resources that had already been committed to the Black Pyramid, and that would now need to be duplicated at the new site. The economic cost of the abandonment was significant. The Black Pyramid represented years of labour and millions of mud bricks that were now wasted, and the new pyramid at Hawara would require a comparable investment of labour and materials. The Hawara Pyramid, the replacement that Amenemhat III built after abandoning the Black Pyramid, was also built of mud brick with a limestone casing. The Hawara Pyramid was somewhat more successful than the Black Pyramid. It was completed, it was used for the pharaoh's burial, and it stood long enough to serve its intended purpose. But the Hawara Pyramid was also structurally compromised. It has eroded significantly over the millennia, and its current condition is not much better than the condition of the Black Pyramid. The structural problems at Hawara were similar to the structural problems at the Black Pyramid. The mud brick core was vulnerable to moisture, the limestone casing was not structurally integrated with the core, and the combination of the two produced a structure that was inherently less durable than the solid stone pyramids of the Old Kingdom. The comparison between the Black Pyramid's anti-robbery passage system and the passage systems of the Old Kingdom pyramids reveals a fascinating asymmetry in the development of the pyramid building tradition, an asymmetry in which the subterranean engineering became more sophisticated while the superstructural engineering became less capable. The Old Kingdom passage systems were relatively simple: a descending passage, one or more chambers, and a system of blocking stones that were intended to seal the passages after the burial was complete. The simplicity reflected the Old Kingdom builders' confidence in the mass of the pyramid itself, the belief that the sheer weight and volume of the stone surrounding the burial chamber would be sufficient to deter tomb robbers and to protect the burial for eternity. The Middle Kingdom passage systems were far more complex. Labyrinthine networks of corridors, dead ends, false floors, concealed openings, and multiple portcullises that were designed to confuse and frustrate robbers who had demonstrated, during the First Intermediate Period, that the Old Kingdom approach of relying on mass alone was insufficient. The complexity reflected the Middle Kingdom builders' awareness that the Old Kingdom strategy had failed. that the mass of the pyramid was not, by itself, sufficient to protect the burial, and that additional measures were needed to prevent the systematic plundering that had stripped the Old Kingdom tombs of their contents. The asymmetry, sophisticated subterranean engineering combined with inferior superstructural engineering, reveals that the knowledge loss was not uniform across all domains of pyramid construction. The Middle Kingdom builders retained significant capability in some areas, particularly in the design of underground spaces, in the cutting and fitting of stone for passage construction, and in the development of anti-robbery measures that required ingenuity and creativity, rather than the brute force capability of quarrying and transporting millions of stone blocks. The capability they lost was specifically the capability for large-scale stone construction. The knowledge of how to quarry, transport, and place limestone blocks at the monumental scale that the Old Kingdom tradition had required. The selective loss of capability is one of the most instructive features of the Black Pyramid story, because it demonstrates that institutional knowledge loss is not an all-or-nothing phenomenon. A civilization does not lose all of its knowledge at once. It loses specific capabilities at different rates, depending on the institutional structures that maintain each capability and on the degree to which each capability depends on continuous practice for its preservation. The capability for large-scale stone construction was particularly vulnerable to loss because it depended on a large, specialized workforce that was expensive to maintain and that could only be sustained by a continuous program of monumental construction. When the program was interrupted, the workforce was dispersed and the capability was lost. The capability for subterranean construction was less vulnerable because it required a smaller workforce, could be sustained by smaller scale projects, and could be maintained even during periods when monumental construction was not being undertaken. The development of the anti-robbery passage system in the Middle Kingdom pyramids, from the relatively simple systems of the early 12th dynasty to the elaborate labyrinth of the Black Pyramid, represents one of the most creative engineering achievements of the period, and deserves detailed examination as evidence of the Middle Kingdom builders' ingenuity and adaptability. The early 12th dynasty pyramids, the pyramids of Amenemhat I and Senusret I at Lisht, had passage systems that were more complex than the Old Kingdom systems, but that were still relatively straightforward in their layout. The passages included portcullises and blocking stones, but they did not include the elaborate network of dead ends, false corridors, and concealed openings that characterized the later 12th dynasty systems. The increasing complexity of the passage systems over the course of the 12th dynasty reflected the builders' growing awareness of the ingenuity and the persistence of the tomb robbers, and their determination to develop countermeasures that would stay ahead of the robbers' capabilities. The Black Pyramid's passage system represented the culmination of this development, the most complex and most sophisticated anti-robbery system ever built in an Egyptian pyramid. The system included multiple levels of deception, corridors that appeared to lead in one direction but that actually led in another, passages that appeared to be blocked but that concealed hidden openings, floors that appeared to be solid but that concealed shafts leading to lower levels. The system was designed to be navigated only by someone who knew the exact sequence of turns, openings, and passages that led from the entrance to the burial chamber, and to confuse and frustrate anyone who did not possess this knowledge. The design of the anti-robbery system required a different kind of engineering knowledge from the knowledge that built the superstructure, a knowledge of spatial planning, of three-dimensional geometry, of the psychology of deception, and of the practical capabilities of the tomb robbers whose intrusion the system was designed to prevent. The knowledge was sophisticated. It required the ability to conceive of complex three-dimensional spaces, to anticipate the behavior of intruders who would be operating in darkness with limited tools, and to design a system that would remain effective even if the intruders were experienced, determined, and willing to spend days or weeks searching for the correct route. The irony of the anti-robbery system is that it was rendered unnecessary by the structural failure of the pyramid itself. The groundwater infiltration that made the substructure unsuitable for burial also made the anti-robbery measures irrelevant because the pharaoh was never buried in the Black Pyramid and the burial chamber never contained the treasures that the system was designed to protect. The most sophisticated anti-robbery system in the history of Egyptian pyramid construction was never tested by actual robbers. It was defeated not by human ingenuity, but by rising water. The Queen's burial chambers within the Black Pyramid's substructure add another dimension to the complexity of the passage system. The chambers were designed to accommodate the burials of two queens, royal women whose status entitled them to burial within the pharaoh's pyramid complex, and whose burial chambers were integrated into the labyrinthine passage system with their own access corridors, their own portcullises, and their own concealed openings. The inclusion of the Queen's burials within the pyramid complex was consistent with the Middle Kingdom convention of combining royal family burials in a single monumental structure, a convention that differed from the Old Kingdom practice of providing separate pyramids for the principal queens. The comparison between the Black Pyramid and the pyramids of the 5th and 6th dynasties, the later Old Kingdom pyramids that were built after the Great Pyramid and that represent the first phase of the tradition's decline, provides additional context for understanding the trajectory of knowledge loss. The 5th and 6th dynasty pyramids were smaller than the 4th dynasty pyramids, reflecting the reduced resources and the diminished ambition of the later Old Kingdom pharaohs. But the 5th and 6th dynasty pyramids were still built of stone, solid limestone cores with stone casing, constructed using the techniques that had been developed during the 4th dynasty, and that were still maintained in attenuated form by the building tradition. The stone construction of the later Old Kingdom pyramids demonstrates that the knowledge of stone construction was not lost immediately after the 4th dynasty. It was attenuated gradually, over the course of several centuries, as the building program contracted, and as the institutional structures that maintained the knowledge were progressively reduced. The transition from the stone pyramids of the later Old Kingdom to the mudbrick pyramids of the Middle Kingdom was not a sudden break. It was the final stage of a gradual process of knowledge erosion that had been underway since the end of the 4th dynasty. The process can be traced through the sequence of pyramids that were built between the Great Pyramid and the Black Pyramid, a sequence that shows a progressive decline in the size, the quality, and the structural ambition of the pyramids, a decline that reflects the progressive attenuation of the institutional knowledge that sustained the tradition. The Great Pyramid was the peak. The 5th dynasty pyramids were a step down. The 6th dynasty pyramids were a further step down. The first intermediate period was the interruption, and the Middle Kingdom pyramids, including the Black Pyramid, were the result of the attempt to revive a tradition that had been declining for centuries, and that had been interrupted for a century and a half. The trajectory of decline is not unique to Egypt. It is a pattern that has been observed in many civilizations, and that reflects the general vulnerability of institutional knowledge to the forces of time, change, and institutional disruption. The Roman building tradition followed a similar trajectory, from the peak of the imperial period, through the gradual decline of the later empire, to the post-Roman period, in which the knowledge of concrete construction was lost, and the building tradition was reduced to simpler methods that could not match the Roman achievements. The Chinese bronze casting tradition followed a similar trajectory, from the peak of the Shang and Zhou dynasties, through the gradual simplification of the later periods, to the eventual loss of specific techniques that could not be replicated by later craftsmen. The universality of the pattern suggests that the knowledge loss is not the result of specific historical circumstances, specific wars, specific political changes, specific economic crises, but of general forces that operate in all civilizations and that produce similar results regardless of the specific circumstances. The general forces include the natural turnover of generations, the tendency of institutions to contract when their funding is reduced, the vulnerability of experiential knowledge to interruptions in the chain of transmission, and the difficulty of maintaining the motivation and the investment that are needed to sustain a tradition of monumental construction over periods of centuries. These forces operated in Egypt, in Rome, in China, and in every other civilization that has built great monuments and then allowed the knowledge that built them to decay. The comparison between the Black Pyramid and the 5th and 6th dynasty pyramids, the later Old Kingdom structures that represent the first phase of decline, provides additional context. These later pyramids were smaller than 4th dynasty ones, but still built of stone, demonstrating that stone construction knowledge was not lost immediately but attenuated gradually over centuries as the building program contracted and institutional structures were reduced. The transition from stone to mud brick was the final stage of a gradual erosion underway since the end of the 4th dynasty. The trajectory can be traced through the sequence. The Great Pyramid was the peak. 5th dynasty pyramids were a step down. 6th dynasty pyramids further. The first intermediate period was the interruption, and Middle Kingdom pyramids, including the Black Pyramid, resulted from attempting to revive a tradition declining for centuries and interrupted for a century and a half. The universality of this pattern, observed in Roman concrete construction, Chinese bronze casting, and many other traditions, suggests knowledge loss results not from specific circumstances, but from general forces. Generational turnover, institutional contraction when funding is reduced, vulnerability of experiential knowledge to transmission interruptions, and difficulty maintaining investment in monumental traditions over centuries. The question of why Amenemhat III chose Djoser despite groundwater challenges reflects the interplay between practical engineering and symbolic politics. Djoser was hallowed ground, site of Sneferu's pyramids, birthplace of the true pyramid tradition, one of the most prestigious funerary locations. Building there connected Amenemhat to Old Kingdom predecessors and proclaimed legitimacy. The prestige may have outweighed practical disadvantages, groundwater problems, distance from the Fayum economic base, and challenging foundation conditions the Middle Kingdom builders were less equipped to handle. The cultural memory of Old Kingdom achievements, preserved in literary texts, religious traditions, and the physical monuments still visible on the horizon, created an impossibly high standard. The Great Pyramid was the product of a unique combination of resources, knowledge, and institutional capacity that the Middle Kingdom could not replicate. But the standard was inescapable, permanent reminders of what the tradition had achieved and how far it had fallen. The psychological impact on the builders must have been significant, knowing they worked with inferior materials, their pyramids unable to match Old Kingdom achievements, the gap visible to everyone who compared new pyramids with old. The relationship between the Black Pyramid and the development of Egyptian funerary religion during the Middle Kingdom provides additional context for understanding the pyramid's significance beyond its engineering characteristics. The Middle Kingdom was a period of significant development in Egyptian religious thought, a period in which the funerary beliefs that had been the exclusive preserve of the pharaoh during the Old Kingdom were gradually extended to the broader population, creating a more democratic approach to the afterlife that had implications for the design and the function of the royal tomb. The democratization of the afterlife, the extension of the funerary beliefs and the funerary practices from the pharaoh to the nobles, the officials, and eventually the common people, changed the context in which the royal pyramid was understood. During the Old Kingdom, the pyramid had been the exclusive instrument of the pharaoh's eternal survival, a unique structure built for a unique individual serving a unique function that no other building could serve. During the Middle Kingdom, the pyramid was still the pharaoh's tomb, but it was no longer the only structure that served the function of ensuring the survival of the deceased in the afterlife. The nobles and the officials had their own tombs, their own funerary equipment, and their own ritual programs that provided for their eternal survival. Programs that were modeled on the pharaohs, but that were adapted to the status and the resources of non-royal individuals. The democratization may have affected the scale and the ambition of the royal pyramid. Because the pyramid was no longer the sole focus of the state's religious investment, but one of many structures that served the funerary needs of the Egyptian population. The state's resources were now divided between the pharaoh's pyramid and the many other tombs and temples that the funerary system required, and the division of resources may have contributed to the reduced scale and the diminished quality of the Middle Kingdom pyramids compared to their Old Kingdom predecessors. The coffin texts. The religious texts that were inscribed on the coffins of Middle Kingdom officials, and that provided the deceased with the spells and the instructions needed for the afterlife journey, represent one of the most important literary developments of the Middle Kingdom and provide context for understanding the religious beliefs that the Black Pyramid was designed to serve. The coffin texts were descendant from the pyramid texts of the Old Kingdom, the religious texts that had been inscribed on the walls of the 5th and 6th dynasty pyramids. But they were adapted for non-royal use, and they reflected the broader, more democratic approach to the afterlife that characterized the Middle Kingdom religious system. The inclusion of the Queen's burials within the Black Pyramid complex, rather than in separate, independent structures, reflects the Middle Kingdom convention of consolidating royal family burials in a single monumental complex. The convention was practical. It reduced the cost of construction by sharing the infrastructure of the funerary complex among multiple burials. But it was also symbolic, emphasizing the unity of the royal family and the connection between the pharaoh and his closest female relatives in the afterlife. The mortuary temple of the Black Pyramid, the ritual center of the funerary complex, has been partially excavated and provides evidence for the ritual program that the complex was designed to serve. The temple included an offering hall, subsidiary chambers for specific ritual purposes, and a courtyard that provided a gathering space for the priests and the officials who participated in the funerary ceremonies. The temple was built of stone, in contrast to the mudbrick pyramid, demonstrating again the selective allocation of stone construction to the elements that the builders considered most important. The mortuary temple of the Black Pyramid, the ritual center of the funerary complex, was built of stone rather than mud brick, demonstrating the selective allocation of stone to the elements the builders considered most important. The temple included an offering hall, subsidiary chambers, and a courtyard for funerary ceremonies. The stone construction of the temple contrasts with the mud brick construction of the pyramid, reinforcing the conclusion that the builder's limited stone construction capability was directed toward the elements that mattered most for the ritual functioning of the complex. The relationship between the Black Pyramid and the development of Egyptian funerary religion during the Middle Kingdom provides additional context. The Middle Kingdom saw the democratization of the afterlife, the extension of funerary beliefs and practices from the pharaoh to nobles, officials, and eventually common people. The democratization changed the context in which the royal pyramid was understood. It was no longer the sole focus of the state's religious investment, but one of many structures serving funerary needs. The division of resources between the pharaoh's pyramid and other funerary structures may have contributed to the reduced scale and diminished quality of Middle Kingdom pyramids. The coffin texts. Religious texts inscribed on Middle Kingdom coffins providing spells and instructions for the afterlife journey, descended from the Old Kingdom pyramid texts, but were adapted for non-royal use, reflecting the broader approach to the afterlife that characterized Middle Kingdom religion. The texts provide context for understanding the beliefs the Black Pyramid was designed to serve. Beliefs about the transformation of the deceased, the journey through the underworld, and the eternal sustenance of the spirit that required the physical infrastructure of the tomb and the ritual infrastructure of the cult. The inclusion of Queen's burials within the pyramid complex, rather than in separate structures, reflected Middle Kingdom convention, practical in reducing construction costs by sharing infrastructure, and symbolic in emphasizing royal family unity in the afterlife. The Queen's chambers were integrated into the labyrinthine passage system, with their own access corridors and portcullises, adding complexity to an already complex subterranean design. The economic impact of the Black Pyramid's abandonment on the Egyptian state was significant. representing not merely the loss of the investment in the pyramid itself, but also the additional cost of building the replacement at Hawara. The double investment, paying for a pyramid that was never used and then paying again for a pyramid that was, consumed resources that could have been directed to other purposes, and that may have contributed to the economic pressures that affected the later 12th dynasty. The economic impact of the abandonment illustrates the real-world consequences of knowledge loss. Consequences that are measured not in abstract terms, but in the specific, quantifiable costs of failed projects, wasted resources, and duplicated investments. The question of what Amenemhat III thought of his failed pyramid, whether he viewed it as a personal humiliation, a theological crisis, or simply a practical problem that required a practical solution, is one that the evidence does not answer directly, but that the circumstantial evidence addresses suggestively. The fact that Amenemhat immediately began construction of a replacement pyramid at Hawara suggests a pragmatic response, a recognition that the Black Pyramid could not serve its purpose, and a determination to build a structure that could. The pragmatism is consistent with the image of Amenemhat III that emerges from other sources, the image of a competent and effective administrator who dealt with problems directly and who did not allow setbacks to derail his program. The abandonment of the Black Pyramid was a setback, but Amenemhat responded to it with the same practical determination that characterized his response to other challenges, redirecting resources to the Hawara site and proceeding with the construction of the replacement pyramid without apparent delay. The Hawara pyramid, the replacement structure that Amenemhat built after abandoning the Black Pyramid, was also built of mud brick with a limestone casing, demonstrating that the pharaoh and his builders had not found a solution to the fundamental material problem that the Black Pyramid had revealed. The Hawara pyramid was somewhat more successful. It was completed, it was used for the pharaoh's burial, and it survived long enough to serve its intended purpose. But the Hawara pyramid was also structurally compromised. It has deteriorated significantly over the millennia, and its current condition confirms that the mud brick material was inadequate for the construction of permanent monumental structures, regardless of the specific design or the specific site conditions. The lesson of the Black Pyramid, the lesson that mud brick cannot sustain pyramidal construction, was confirmed rather than refuted by the Hawara pyramid's experience. The archaeological evidence for the Black Pyramid's construction workforce, while less extensive than the evidence from Giza, provides some information about the organization and the composition of the labor force. The workforce included skilled stonecutters for the substructure, brickmakers for the superstructure, transport workers for the movement of materials, and administrative staff for the management of the project. The workforce was probably smaller than the Old Kingdom pyramid workforces, reflecting the reduced scale of the project and the reduced complexity of the construction. But it was still substantial, numbering in the hundreds or thousands at peak periods, and requiring the same kind of logistical support system that the Old Kingdom projects had required. The chronological relationship between the Black Pyramid's abandonment and the beginning of construction at Hawara has been estimated by scholars on the basis of the construction evidence at both sites. The estimates suggest that the transition was relatively rapid. The construction at Hawara may have begun within a year or two of the decision to abandon the Black Pyramid, indicating that the pharaoh and his administrators acted quickly to secure an alternative burial site once the decision to abandon had been made. The rapid transition reflects the urgency of the situation. The pharaoh was aging. His need for a completed tomb was growing more pressing with each passing year, and the delay caused by the abandonment of the Black Pyramid could not be allowed to extend indefinitely. The urgency motivated the efficiency of the Hawara construction, a project that was completed in a relatively short period using methods and materials that were essentially the same as those used at the Black Pyramid, applied to a site that offered somewhat better conditions for the preservation of the burial. The tools used for the Black Pyramid's construction included the standard Old Kingdom toolkit, copper chisels and stone hammers for the stone cutting work in the substructure, wooden molds for the manufacture of mud bricks, wooden sledges for the transport of materials, and measuring instruments for the surveying and alignment of the structure. The continuity of the toolkit demonstrates that the loss of knowledge was not a loss of tools. The Middle Kingdom builders had access to the same tools that the Old Kingdom builders had used. The loss was a loss of the knowledge of how to use the tools at monumental scale, the specific, practical knowledge of how to organize the quarrying, the transport, and the placement of millions of stone blocks that the Old Kingdom builders had possessed, and that the Middle Kingdom builders had lost. The development of the anti-robbery passage system over the course of the 12th dynasty, from the relatively simple systems of the early dynasty to the elaborate labyrinth of the Black Pyramid, represents one of the most creative engineering sequences of the period. The early 12th dynasty pyramids had passage systems that included portcullises and blocking stones, but lacked the elaborate dead ends and concealed openings of the later systems. The increasing complexity reflected the builders' growing awareness of tomb robbers' ingenuity and persistence, and their determination to develop countermeasures staying ahead of the robbers' capabilities. The Black Pyramid system was the culmination, most complex anti-robbery system ever built in an Egyptian pyramid. It included multiple levels of deception, corridors appearing to lead in one direction but actually leading in another, passages appearing blocked but concealing hidden openings, floors appearing solid but concealing shafts to lower levels. The system required someone to know the exact sequence of turns, openings, and passages leading to the burial chamber, and was designed to confuse anyone lacking this knowledge. The design required knowledge different from superstructure engineering, knowledge of spatial planning, three-dimensional geometry, the psychology of deception, and the practical capabilities of tomb robbers. The knowledge was sophisticated, requiring the ability to conceive complex three-dimensional spaces, anticipate intruder behavior in darkness with limited tools, and design a system remaining effective even against experienced and determined robbers willing to spend extended periods searching. The irony is that the system was rendered unnecessary by the structural failure itself. Groundwater infiltration that made the substructure unsuitable for burial also made anti-robbery measures irrelevant, since the pharaoh was never buried in the Black Pyramid and the chamber never contained the treasures the system was designed to protect. The most sophisticated anti-robbery system in Egyptian pyramid history was never tested by actual robbers, defeated not by human ingenuity, but by rising water. The comparison between the Black Pyramid and the contemporary monuments of other civilizations confirms that the Middle Kingdom builders were not incompetent by the standards of their time. The Middle Kingdom was contemporary with the Middle Bronze Age civilizations, Mesopotamian city-states, Cretan palaces, emerging Levantine kingdoms. The monumental construction of the Middle Kingdom was impressive by contemporary standards, and the engineering skill demonstrated in the substructure equaled or exceeded the subterranean engineering capability of any other Near Eastern civilization. The builders were skilled, creative, and capable, working within constraints imposed by a tradition that had lost its most demanding capability. The Mesopotamian ziggurats provide an instructive comparison, also built of mud brick, and experiencing similar structural problems, including erosion, settlement, and moisture damage. The comparison demonstrates that the mud brick limitation was universal, affecting every civilization building monumental structures from earth-based materials. The difference between Egypt and Mesopotamia lay not in materials but in expectations. The Egyptians expected eternal permanence. The Mesopotamians accepted periodic rebuilding. The Egyptian expectation of permanence combined with the impermanent material produced the contradiction the Black Pyramid embodies. The construction of the substructure required the removal of thousands of cubic meters of bedrock, a substantial excavation that was accomplished using the same techniques of stone cutting and removal that had been developed during the Old Kingdom, and that the Middle Kingdom builders still possessed. The stone cutting work in the substructure was of high quality. The passages and chambers were carefully cut, The surfaces were well finished, and the dimensions were precise. The quality of the subterranean stonework contrasts sharply with the quality of the mudbrick superstructure, a contrast that reinforces the conclusion that the Middle Kingdom builders retained their capability for small-scale and medium-scale stone construction, while losing their capability for the large-scale stone construction that the pyramid superstructure required. The Black Pyramid's substructure also contained burial chambers for 2 queens, additional spaces that were integrated into the labyrinthine passage system, and that were designed to provide the queens with the same level of protection and the same quality of burial accommodation as the pharaoh himself. The inclusion of the queen's burials within the pyramid complex was consistent with the Middle Kingdom practice of combining the burials of the pharaoh and his closest family members in a single monumental structure, a practice that differed from the Old Kingdom convention of providing separate pyramid complexes for the queens. The portcullis system of the Black Pyramid was one of the most elaborate ever constructed, a series of massive stone blocks that were designed to be lowered into position to block the passages after the burial was complete. The blocks were held in raised positions by props during the construction, props that could be removed by the burial party after the interment was complete, allowing the blocks to drop into their final positions and to seal the passages against intrusion. The system was ingenious, but it was also vulnerable to the same groundwater problems that affected the rest of the substructure. The rising water saturated the stone blocks, weakened the surrounding bedrock, and may have caused some of the portcullises to shift or to fail before they could serve their intended purpose. The fifth exploration examines the broader context of Middle Kingdom pyramid construction, the tradition within which the Black Pyramid was built, and the constraints that the tradition imposed on the builders' ambitions. The Middle Kingdom pyramid tradition was a tradition of diminished capability, a tradition that preserved the form of the Old Kingdom pyramid, but that lacked the engineering substance that had made the form structurally viable. The Middle Kingdom builders knew what a pyramid was supposed to look like. They had the Old Kingdom pyramids as models, standing on the horizon as visible reminders of what their ancestors had achieved. But knowing what a pyramid was supposed to look like is not the same as knowing how to build one. And the gap between the visual knowledge, what a pyramid looks like, and the practical knowledge, how to build one that stands, was the gap that the Black Pyramid's failure revealed. The sixth exploration examines what the Black Pyramid tells us about the nature of institutional knowledge, about how knowledge is created, how it is maintained, and how it can be lost. The Black Pyramid is the most eloquent monument to institutional knowledge loss in the ancient world, a structure that demonstrates, through its failure, the consequences of losing the specific, practical, experiential knowledge that sustained the pyramid building tradition. The knowledge was not lost through catastrophe. It was not destroyed by war, by natural disaster, or by deliberate suppression. The knowledge was lost through neglect, through the gradual, imperceptible, generation by generation erosion of institutional capability that occurs when the institutions that maintain the knowledge are underfunded, reorganized, or simply allowed to fade away. The erosion was slow, so slow that the people who were living through it may not have noticed it, may not have recognized that the knowledge their predecessors had possessed was being lost, may not have understood that the gap between what they knew and what their ancestors had known was growing wider with each passing generation. Step back now from the structural analysis and the archaeological details and the engineering comparisons. Step back from the Black Pyramid as a building and look at it as something else, as a warning about what happens when the knowledge that sustains a civilization is allowed to decay, a warning about the fragility of institutional capability and the ease with which the achievements of one generation can be lost to the next. A warning that is as relevant to the modern world as it was to the Middle Kingdom builders, who discovered, through the failure of their pyramid, that the knowledge of their ancestors was no longer available to them. The warning is this: knowledge is not permanent. Knowledge must be actively maintained, actively taught, actively practiced, actively transmitted from one generation to the next. The maintenance requires investment. Investment in training, investment in institutional structures, investment in the apprenticeship systems and the professional communities that carry the knowledge and that ensure its transmission. Without the investment, the knowledge decays, gradually, imperceptibly, one generation at a time, until the gap between what the current generation knows and what the previous generations knew becomes too great to bridge. Let that sink in. The Black Pyramid is the physical embodiment of the gap. The Great Pyramid, standing on the Giza Plateau, visible from the Black Pyramid's site on clear days, is the physical embodiment of what the knowledge could produce when it was maintained. The contrast between the two structures, the one standing firm after 4,500 years, the other collapsing into rubble after less than 4,000, is the contrast between knowledge maintained and knowledge lost, between a tradition sustained and a tradition broken, between a civilization at the peak of its capability and a civilization that has lost the capability it once possessed. This is not science fiction. This is the actual history of one of the greatest civilizations in human history. A civilization that built the most impressive stone structures the world has ever seen, and that then, over the course of 8 centuries, lost the ability to build them. The loss was not dramatic. It did not happen in a single catastrophic event. The loss was gradual, so gradual that the people who were living through it may not even have noticed it. The Great Pyramid was built. The pyramid building program continued for a few more centuries, producing progressively smaller and less impressive structures. The program was interrupted by the collapse of the Old Kingdom. The program was revived by the Middle Kingdom pharaohs. But the revived program used mudbrick instead of stone because the knowledge of how to build in stone at monumental scale had been lost during the interruption. The Black Pyramid is the result. A pyramid that looks like a pyramid from the outside, but that is structurally different from the Old Kingdom pyramids in every respect that matters. Let that sink in. The modern world faces the same risk. The knowledge that maintains the most critical systems of modern civilization, the power grids, the water treatment plants, the transportation networks, the digital infrastructure, is held primarily in the minds of the people who operate and maintain these systems. The knowledge is practical, experiential, and embodied, the same kind of knowledge that built the Great Pyramid and that was lost before the Black Pyramid was built. The knowledge is vulnerable to the same forces that destroyed the Old Kingdom building tradition: retirement, institutional reorganization, budget cuts, and the simple passage of time. The modern world's knowledge is more extensively documented than the ancient Egyptian knowledge was, written down in manuals and databases and training materials that the ancient builders did not have. But documentation is not knowledge. A manual is not a substitute for experience. A database is not a substitute for skill, and a training manual is not a substitute for the hands-on apprenticeship that the ancient builders used to transmit their craft from one generation to the next. The question of why the Middle Kingdom pharaohs continued to build pyramids, why they persisted with a form that their diminished knowledge could not adequately support, is a question that connects the engineering story to the religious and political dimensions of Egyptian civilization. The pyramid was not merely a building, it was a symbol, a statement of royal authority, a demonstration of the pharaoh's connection to the divine order, and a necessary instrument for the pharaoh's eternal survival. The Middle Kingdom pharaohs could not abandon the pyramid form without abandoning the religious and political claims that the form embodied: the claim to divine kingship, the claim to cosmic authority, the claim to be the legitimate successors of the Old Kingdom pharaohs who had built the original pyramids. The persistence of the pyramid form, despite the diminished capability, was therefore not irrational. It was a rational response to the political and religious pressures that the Middle Kingdom pharaohs faced. The pharaohs needed pyramids, not merely because they wanted them, but because the political and religious system required them, because the legitimacy of the dynasty depended on the construction of monuments that connected the current pharaoh to the divine tradition of the Old Kingdom, and because the absence of a pyramid would have been interpreted as a sign of weakness, of illegitimacy or of the pharaoh's failure to fulfill his cosmic responsibilities. The pressure to build pyramids, despite the diminished capability, produced the compromises that characterized the Middle Kingdom pyramid tradition. The substitution of mudbrick for stone, the use of limestone casing to create the appearance of a stone pyramid, and the acceptance of structural standards that were far lower than the standards of the Old Kingdom. The compromises were not ideal. They produced structures that were less durable, less stable, and less impressive than their Old Kingdom predecessors. But the compromises were necessary because the alternative, the abandonment of the pyramid form entirely, was politically and religiously unacceptable. The Black Pyramid is the most dramatic illustration of the consequences of these compromises, a structure that was conceived with the ambition of the Old Kingdom, but that was executed with the diminished capability of the Middle Kingdom, and that failed because the gap between the ambition and the capability was too great. The failure was not merely structural, it was symbolic, a visible demonstration that the Middle Kingdom pharaohs could not match the achievements of their Old Kingdom predecessors, that the tradition had been diminished, and that the knowledge that had sustained the tradition was no longer available. The question of whether the Middle Kingdom pharaohs were aware of their diminished capability, whether they recognized that they were building with inferior materials and methods compared to their Old Kingdom predecessors, is a question that the evidence does not definitively answer, but that the circumstantial evidence addresses suggestively. The Middle Kingdom pharaohs could see the Old Kingdom pyramids. The monuments were still standing, still visible, still available for comparison with the Middle Kingdom constructions. The contrast between the solid stone of the Old Kingdom pyramids and the mud brick of the Middle Kingdom pyramids would have been apparent to any observer, and the pharaohs, as the patrons and the commissioners of the construction, would certainly have been aware of the difference. The awareness may have been a source of frustration, a recognition that the current tradition was not capable of matching the achievements of the past, that the monuments being built were inferior to the monuments that had been built 8 centuries earlier, and that the gap between the current capability and the historical standard was visible to everyone who saw the new pyramid alongside the old. The frustration may have motivated the compensatory measures that the Middle Kingdom pharaohs adopted. The elaborate subterranean passage systems, the complex ritual programs, the ambitious temple complexes that surrounded the pyramids and that provided, in their scale and their sophistication, a partial compensation for the diminished quality of the pyramids themselves. The labyrinth at Hawara, the vast temple complex that Amenemhat III built adjacent to his second pyramid, may have been partly a response to this frustration. The labyrinth was, according to ancient descriptions, one of the most impressive buildings in Egypt, a complex of thousands of rooms, corridors, and courtyards that was larger and more elaborate than any mortuary temple that had been built during the Old Kingdom. The labyrinth may have been Amenemhat III's answer to the gap between his pyramids and the pyramids of the Old Kingdom, a monument that exceeded the Old Kingdom achievements in one domain, the complexity and the scale of the temple complex, even as it fell short of those achievements in another, the structural quality and the durability of the pyramid itself. The relationship between the Black Pyramid and the broader pattern of institutional knowledge loss in human history provides the final layer of meaning in the pyramid's story. The Black Pyramid is not unique. It is one example of a pattern that has repeated itself in every civilization and every era of human history, the pattern in which the achievements of one generation are lost to the next, because the knowledge that sustained those achievements was not adequately maintained. The pattern is visible in the history of Roman engineering, where the sophisticated road building and aqueduct construction techniques of the imperial period were lost during the post-Roman centuries and were not recovered until the modern era. The pattern is visible in the history of Chinese ceramics, where the techniques for producing certain types of porcelain were lost and then rediscovered after centuries of absence. The pattern is visible in the history of medieval European architecture, where the techniques of Roman concrete construction were lost and replaced by less durable stone and mortar techniques that would not match the Roman achievement for more than 1,000 years. The question of what the modern world should learn from the Black Pyramid connects the ancient story to contemporary policy debates about workforce development, institutional knowledge management, and the allocation of resources to the maintenance of critical capabilities. The debates are practical. They involve decisions about how much to invest in training, how much to invest in documentation, and how much to invest in the institutional structures that maintain the knowledge on which critical systems depend. The Black Pyramid provides a framework for these debates. A concrete, historical, 4,000-year-old demonstration of the consequences of allowing institutional knowledge to decay, and a reminder that the consequences are not abstract but physical, structural, and measurable. The framework is simple: maintain the knowledge or lose the capability. The Great Pyramid demonstrates the capability that maintained knowledge can produce. The Black Pyramid demonstrates the capability that lost knowledge cannot sustain. The distance between the two is the cost of the neglect, the cost that a civilization pays when it fails to invest in the maintenance of the knowledge that sustains its most important capabilities. The cost is not theoretical, it is physical, measurable in meters of height, in megapascals of compressive strength, in centuries of survival, and the cost is permanent. Once the knowledge is lost, the capability cannot be recovered without regenerating the knowledge through a new program of comparable scale and expense. The comparison between the Black Pyramid and the contemporary monuments of other civilizations provides additional perspective on the achievements and the limitations of the Middle Kingdom building tradition. The Middle Kingdom was contemporary with the Middle Bronze Age civilizations of the Near East, the city-states of Mesopotamia, the palaces of Crete, the emerging kingdoms of the Levant. The monumental construction of the Middle Kingdom, even in its diminished form, was impressive by the standards of the contemporary world, and the engineering skill that the Black Pyramid's substructure demonstrates was equal to or greater than the subterranean engineering capability of any other civilization in the ancient Near East. The Middle Kingdom builders were not incompetent. They were skilled, creative, and capable engineers who were working within the constraints of a tradition that had lost its most demanding capability. The constraints were real, but the skill that the builders brought to the work within those constraints was genuine. The modern relevance of the Black Pyramid's story, the applicability of its lesson about institutional knowledge loss to the challenges facing contemporary civilization, is one of the most compelling aspects of the pyramid's significance. The modern world faces its own versions of the knowledge loss that produced the Black Pyramid, its own instances of institutional capability being eroded by budget cuts, organizational restructuring, retirement, and the simple passage of time. The parallels are direct. The mechanisms of knowledge loss are the same in the modern world as they were in ancient Egypt, and the consequences of the loss are the same: diminished capability, structural failure, and the inability to maintain the systems that the knowledge had sustained. The nuclear industry provides one of the most striking modern parallels. The knowledge that was developed during the early decades of the nuclear age, the knowledge of how to design, build, and operate nuclear facilities, was held primarily in the minds of the engineers and the operators who had developed it through years of hands-on experience. As those engineers and operators have retired, the knowledge they carried has been progressively attenuated, and the nuclear industry has faced the challenge of maintaining its institutional capability in the face of the retirement of its most experienced personnel. The challenge is real, and the Black Pyramid story reminds us that the challenge is not new, that civilizations have been facing the same challenge for millennia, and that the failure to meet the challenge has consequences that can be measured not in abstract terms but in physical, structural, concrete terms. The aerospace industry provides another parallel. The knowledge that built the Saturn V rocket, the vehicle that carried human beings to the moon, was held primarily in the minds of the engineers who designed and built it. When the Apollo program ended and the Saturn V production line was shut down, the knowledge began to erode. The engineers retired, the institutional structures were disbanded, and the practical knowledge that had been accumulated during the program was gradually lost. The consequence is that the modern aerospace industry cannot build a Saturn V, not because the technology is beyond its capability, but because the specific, practical, experiential knowledge that was needed to build the vehicle has been lost, and the cost of regenerating that knowledge would be comparable to the cost of developing an entirely new vehicle. The parallel with the Black Pyramid is exact. The Saturn V knowledge, like the Great Pyramid knowledge, was generated through a program of sustained, expensive, state-funded effort. The knowledge was held in the minds of the people who did the work. The knowledge was lost when the program was ended and the people retired. And the consequence of the loss is that the capability cannot be replicated without regenerating the knowledge through a new program of comparable scale and expense. The Black Pyramid is the ancient Saturn V, the monument to the consequences of allowing the institutional knowledge that sustains a civilization's greatest capabilities to decay. The nuclear industry parallel deserves extended discussion because it provides the most direct modern analog to the knowledge loss that produced the Black Pyramid. The nuclear industry was built by a generation of engineers who developed their knowledge through decades of hands-on experience that was accumulated during the design, construction, and operation of the first generation of nuclear facilities. The knowledge was practical and experiential, the kind of knowledge that can only be gained by doing the work, by encountering the problems, and by developing the solutions through direct engagement with the physical systems. As the first generation of nuclear engineers has retired, the industry has faced the challenge of maintaining its institutional capability, of ensuring that the knowledge accumulated over decades of experience is not lost when the people who carry it leave the workforce. The challenge is real. The nuclear industry has documented cases of knowledge loss that have affected the operation and the maintenance of critical facilities, and the industry has invested significant resources in knowledge management programs that are designed to capture, preserve, and transmit the experiential knowledge of the retiring workforce. The parallel with the Black Pyramid is exact in its structure, a body of critical institutional knowledge generated through decades of expensive state-funded effort, held primarily in the minds of the practitioners, and vulnerable to loss through the retirement or departure of the knowledge holders. The parallel is also exact in its consequences. The loss of the knowledge produces a gap between the current capability and the historical capability, a gap that manifests itself in diminished performance, in structural problems, and in the inability to maintain the systems that the knowledge had sustained. The aerospace parallel is equally instructive. The Saturn V knowledge, the specific practical knowledge of how to design, build, and operate the vehicle that carried human beings to the moon, was lost when the Apollo program ended. The loss was not deliberate. It was the natural consequence of ending a program and dispersing a workforce, the same natural consequence that produced the knowledge loss between the Old Kingdom and the Middle Kingdom. And the consequence of the loss is the same. The capability cannot be replicated without regenerating the knowledge through a new program of comparable scale and expense. The question of what lessons the modern world should draw from the Black Pyramid story is not merely academic. It is practical because the mechanisms of knowledge loss that destroyed the Egyptian building tradition are the same mechanisms that threaten the institutional knowledge of modern civilization. The mechanisms are universal. They operate in every organization, in every institution, in every professional community that depends on experiential knowledge for its core capabilities. The mechanisms include retirement, the departure of experienced practitioners who carry the most valuable and the most difficult to replace knowledge. The mechanisms include institutional reorganization, the restructuring of organizations that disrupts the relationships and the routines through which knowledge is transmitted. The mechanisms include budget cuts, the reduction of funding for training, for apprenticeship, and for the knowledge management programs that are designed to capture and to preserve experiential knowledge. And the mechanisms include the simple passage of time, the natural erosion of institutional memory that occurs as each generation passes its knowledge to the next, with inevitable losses of detail, of nuance, and of practical understanding. The experience of standing at the Black Pyramid and looking north toward the Red Pyramid, seeing both structures simultaneously, the solid stone monument of the Old Kingdom and the eroded mud brick mound of the Middle Kingdom, standing on the same plateau, separated by 8 centuries and by the immeasurable distance between maintained knowledge and lost knowledge, is one of the most powerful experiences that the Egyptian archaeological landscape can offer. The contrast is immediate, visceral, and unavoidable. The Red Pyramid stands tall, its form intact, its structure sound, while the Black Pyramid slumps, its form obliterated, its structure dissolved. The stark and unforgiving contrast tells the story more eloquently than any written text could. The story of what knowledge can build and what the absence of knowledge cannot sustain. The experience of standing at the Black Pyramid and looking toward the Red Pyramid, seeing both simultaneously on the same plateau, is one of the most powerful experiences the Egyptian landscape offers. The contrast is immediate and unavoidable. The Red Pyramid standing tall with its form intact, the Black Pyramid slumping with its form obliterated. The stark and unforgiving contrast tells the story more eloquently than any written text. The haunting story of what carefully maintained knowledge can build and what tragically lost knowledge cannot sustain. The quiet but devastating grief moment of the Black Pyramid story is not the collapse of the structure. It is the realization that the collapse was unnecessary. The knowledge had once existed, it was real and proven. It had been generated at truly enormous cost. Through the collapses at Maydum, the crises at the Bent Pyramid, the experiments at the Red Pyramid, and the perfection at Giza. The knowledge was real. It was validated. It was sufficient for the construction of the most impressive stone structures in the ancient world. And it was lost, not through catastrophe, but through neglect. Through the failure to invest in the institutions that maintained it, through the failure to train the next generation of builders, through the failure to recognize that the knowledge was as important as the monuments it produced, and that the failure to actively maintain and transmit the knowledge would eventually and inevitably mean the failure to maintain the monuments. The Black Pyramid stands on the Djoser Plateau, a low, dark, eroded mound that bears almost no resemblance to the smooth, gleaming pyramid that Amenemhat III intended to build. The mound is surrounded by the remains of the limestone casing, fragments of stone that have separated from the mud brick core, and that lie scattered around the base like the shed skin of a creature that has outgrown its armor. The core itself is exposed, the dark mud brick visible beneath the remnants of the stone veneer, the material reality of the structure revealed by the loss of the cosmetic surface that was designed to conceal it. The exposure of the mud brick core is itself a lesson, a visual demonstration of the difference between appearance and substance, between the surface that the builders wanted the world to see and the reality that lay beneath it. The limestone casing created the appearance of a stone pyramid, a monument that looked, from the outside, like the great pyramids of the Old Kingdom. But the appearance was a deception. Beneath the stone surface, the pyramid was mud brick, and the mud brick was not adequate for the task. The deception was not deliberate. The builders were not trying to fool anyone. They were doing the best they could with the knowledge they had, but the best they could do was not good enough. And the failure of the mud brick core beneath the stone veneer is the visible evidence of the gap between the knowledge they had and the knowledge they needed. The implications of the Black Pyramid for the modern world are direct and unsettling. The modern world relies on institutional knowledge, on the accumulated expertise of engineers, operators, and maintainers who keep the critical systems of civilization functioning. The knowledge is as vulnerable as the knowledge that built the Great Pyramid. Vulnerable to retirement, to institutional change, to budget cuts, and to the simple passage of time. The Black Pyramid demonstrates what happens when the knowledge is lost. The systems fail, the structures collapse, and the civilization that depended on them is diminished. The demonstration is not abstract. It is concrete, a dark mound of eroding mud brick on the Djoser Plateau, standing within sight of the Red Pyramid and the Bent Pyramid, monuments that were built with the knowledge that the Black Pyramid's builders had lost. The archaeological study of the Black Pyramid has been conducted by several generations of scholars, beginning with the early explorers who first identified the structure as a pyramid and continuing through the systematic excavations that have revealed the complexity of the substructure and the severity of the structural problems that the builders encountered. The most important modern study of the Black Pyramid was conducted by the German Archaeological Institute under the direction of Dieter Arnold, a scholar whose meticulous fieldwork and careful analysis established the definitive account of the pyramid's construction history, its structural problems, and its relationship to the broader tradition of Middle Kingdom pyramid building. Arnold's work revealed the full extent of the subterranean passage system, the labyrinthine network of corridors, chambers, and dead ends that the builders had designed to protect the pharaoh's burial. The documentation of the passage system was itself a significant achievement. The passages are narrow, the spaces are confined, and the rising groundwater has made many areas of the substructure inaccessible or dangerous to enter. Arnold's team mapped the accessible areas with precision, recording the dimensions, the orientations, and the construction details of each passage and chamber, and producing plans and sections that reveal the full complexity of the system and the ingenuity of the anti-robbery measures that the builders incorporated into the design. Arnold's analysis of the structural problems confirmed the basic picture that earlier scholars had suggested. The picture of a mud brick pyramid that was undermined by groundwater infiltration that was abandoned before the pharaoh's burial, because the structural damage had rendered the substructure unsuitable for its intended purpose. The analysis also revealed new details. Details about the specific sequence in which the structural problems developed, about the measures that the builders took to address the problems, and about the decision-making process that led to the abandonment of the pyramid and the construction of the replacement at Hawara. The Black Pyramid's relationship to the other Middle Kingdom pyramids at Djoser, particularly the White Pyramid of Amenemhat II and the Pyramid of Senusret III, provides additional context for understanding the development and the decline of the Middle Kingdom pyramid tradition. The White Pyramid, built by Amenemhat II roughly 50 years before the Black Pyramid, was also built of mud brick with a limestone casing, and it has suffered a similar fate, deteriorating over the millennia into an eroded mound that is barely recognizable as a pyramid. The Pyramid of Senusret III, built roughly 30 years before the Black Pyramid, was also built of mud brick, and it too has deteriorated significantly, though its substructure, like the Black Pyramids, reveals the sophistication of the Middle Kingdom builders' underground engineering. The clustering of Middle Kingdom pyramids at Djoser, alongside the Old Kingdom pyramids of Sneferu, creates an archaeological landscape that tells the entire story of the pyramid building tradition in a single site. The Red Pyramid and the Bent Pyramid represent the peak of the tradition, the moment of maximum capability and maximum achievement. The Middle Kingdom pyramids represent the decline, the moment when the capability had been diminished and the achievements were correspondingly reduced. The contrast between the two groups of pyramids, the solid stone of the Old Kingdom structures and the crumbling mud brick of the Middle Kingdom structures, is the most eloquent visual expression of the knowledge loss that occurred between the two periods. The future of the Black Pyramid, its prospects for survival, and its likely condition in the coming centuries and millennia is a subject of concern for the archaeologists and the conservators who are responsible for the preservation of the Djoser monuments. The mud brick core of the Black Pyramid is inherently fragile. It will continue to deteriorate under the influence of wind erosion, moisture infiltration, and the simple force of gravity that is slowly pulling the eroded mass downward and outward. The conservation measures that are currently in place, the drainage systems, the surface stabilization treatments, the monitoring of the structure's condition, will slow the deterioration but will not stop it. The Black Pyramid will continue to erode, gradually, inexorably, year by year, until the remaining structure is completely absorbed by the desert from which it was built. The prospect of the Black Pyramid's eventual disappearance adds an additional layer of urgency to the study and the documentation of the site, an urgency that motivates the ongoing archaeological and conservation work, and that underscores the importance of recording the physical evidence before it is lost. The documentation of the Black Pyramid, the plans, the photographs, the measurements, the analysis, is the modern equivalent of the knowledge transmission that the Middle Kingdom builders failed to accomplish. The preservation, in written and visual form, of the knowledge that the physical structure embodies, so that the knowledge will survive even after the structure itself has disappeared. The ongoing conservation work at the Black Pyramid has focused on the stabilization of the remaining structure and the prevention of further deterioration. The work is challenging. The mud brick core is inherently fragile, the groundwater continues to infiltrate the substructure, and the desert environment subjects the exposed surfaces to continuous erosion by wind and sand. The conservation measures include the reinforcement of weakened areas with modern materials, the installation of drainage systems to reduce the groundwater level around the substructure, and the monitoring of the structure's condition over time to detect and address new problems before they become irreversible. The conservation work is essential. Without it, the Black Pyramid would continue to deteriorate until the remaining structure was completely lost, and the physical evidence for one of the most important episodes in the history of Egyptian architecture would disappear. The philosophical dimensions of the Black Pyramid's story, the questions about knowledge, permanence, and the relationship between ambition and capability that the pyramid raises, provide a framework for reflection that extends beyond the specific context of Egyptian architecture to the broadest questions about human civilization and its prospects. The first philosophical dimension is the question of permanence, the question of whether the desire for permanent monuments is compatible with the impermanent nature of human knowledge. The Egyptian pharaohs desired permanence. They wanted their tombs to last forever, to endure through all of time, to provide a permanent home for their spirits in the afterlife. The desire was sincere. It was the deepest aspiration of the Egyptian religious system, and it motivated every aspect of the pyramid building program. But the desire for permanent monuments collided with the impermanent nature of the knowledge that built them. The knowledge was held in human minds, transmitted through human institutions, and vulnerable to the same forces of change and decay that affect all human things. The collision produced the Black Pyramid, a monument that was designed for permanence, but that was built with impermanent knowledge, and that failed because the knowledge failed before the monument could achieve the permanence it was designed for. The second philosophical dimension is the question of succession, the question of whether the achievements of one generation can be transmitted to the next, whether the knowledge that produces great achievements can be preserved across the transitions of power, the changes of dynasty, and the disruptions of political instability that characterize all human civilizations. The Egyptian answer was mixed. The knowledge was transmitted successfully across some transitions, from Sneferu to Khufu, for example, but was lost across others, from the Old Kingdom to the Middle Kingdom. The mixed answer suggests that the transmission of knowledge is contingent, dependent on specific institutional conditions that may or may not be present during any given transition, and vulnerable to disruption by the same political and social forces that produce the transitions themselves. The visitor who comes to the Black Pyramid today encounters a structure that is difficult to read, a low, dark mound that does not immediately reveal its identity as a pyramid or its significance in the history of Egyptian architecture. The mound is not impressive. It does not tower above the landscape. It does not catch the light, and it does not command the attention the way the nearby Red Pyramid and Bent Pyramid do. The visitor must bring knowledge to the site. Knowledge of the pyramid's history, knowledge of its construction, knowledge of its failure, in order to understand what the mound represents and why it matters. The knowledge that the visitor brings to the site is, in a sense, the reverse of the knowledge that the builders lacked. The visitor knows the full story, from the Old Kingdom peak to the Middle Kingdom decline, and the visitor can see the Black Pyramid in its proper context as a monument to institutional knowledge loss. The builders did not have this perspective. They were living inside the story, working within the constraints of a diminished tradition, doing their best with the knowledge they had. The visitor has the advantage of hindsight, the ability to see the full arc of the tradition, and to understand the Black Pyramid's place within it. The hindsight is a privilege, and the privilege carries a responsibility, the responsibility to learn from the Black Pyramid's story, and to apply the lesson to the modern world's own challenges of institutional knowledge maintenance. The comparison between the Black Pyramid and its Old Kingdom neighbours is inescapable, and the comparison is devastating. The Red Pyramid, built 8 centuries earlier, using solid limestone blocks, with the knowledge that Sneferu's building program had generated, stands 104 meters tall, structurally sound, its form essentially unchanged since the day it was completed. The Black Pyramid, built 8 centuries later, using mudbrick, without the knowledge that the Old Kingdom builders had possessed, stands as a collapsed mound, its form obliterated, its structure disintegrated, its purpose unfulfilled. The contrast is the measure of the knowledge loss, the visible, quantifiable, unmistakable measure of what was lost when the institutional knowledge of the Old Kingdom pyramid builders was allowed to decay. The pyramidion of the Black Pyramid sits in the Egyptian Museum in Cairo, a dark stone capstone inscribed with hieroglyphs designed to crown a pyramid that was never used for its intended purpose. The pyramidion is beautiful, its dark surface polished to a gleam, its inscriptions carefully carved, its proportions elegant and precise. The pyramidion is also alone, separated from the structure it was designed to crown, displayed in a museum rather than standing at the apex of a pyramid, a capstone without a pyramid, a crown without a king. The separation of the pyramidion from its pyramid is the final metaphor of the Black Pyramid's story. The story of a civilization preserved the form while losing the substance, that maintained the symbols while losing the knowledge that gave them meaning, and that discovered, through the failure of its greatest monument, that the gap between ambition and capability cannot be bridged by ambition alone. The pyramidion survives because it was made of stone, hard, durable, resistant to the forces that destroyed the mud brick pyramid beneath it. The pyramid collapsed because it was made of mud brick, soft, fragile, vulnerable to the moisture and the gravity that the stone pyramids of the Old Kingdom had been designed to resist. The Black Pyramid's story does not end with its abandonment. The story continues. In the Hawara pyramid that Amenemhat III built as a placement in the continued decline of the pyramid tradition after the 12th dynasty, in the eventual abandonment of the pyramid form entirely by the New Kingdom pharaohs, who chose to be buried in rock-cut tombs in the Valley of the Kings, and in the long, slow process of decay that has transformed the Middle Kingdom pyramids from monumental structures into eroded mounds of mud brick and scattered limestone fragments. The Hawara pyramid, the replacement that Amenemhat III built after abandoning the Black Pyramid, was somewhat more successful than its predecessor. It was completed, it was used for the pharaoh's burial, and it was associated with the famous labyrinth, the vast temple complex that ancient writers described as one of the most impressive buildings in Egypt. But the Hawara pyramid was also built of mud brick with a limestone casing, and it has suffered the same fate as the Black Pyramid. Its casing has been stripped, its core has eroded, and its current condition is little better than the condition of the pyramid it was built to replace. The Hawara pyramid's survival, slightly longer than the Black Pyramid's, is a difference of degree rather than of kind. Both structures were built with the same diminished knowledge. Both structures were doomed by the same structural limitations. And both structures have been reduced by the passage of time to the same condition of ruin. The trajectory from the Great Pyramid to the Black Pyramid, from the peak of the tradition to its decline, is the trajectory of institutional knowledge loss. The trajectory is not unique to Egypt, it is a universal pattern, observable in every civilization that has built great institutions and then allowed the knowledge that sustained those institutions to decay. The pattern is recognizable. The initial achievement, the period of maintenance, the gradual decline, the loss of capability, and the eventual failure of the systems that the knowledge had supported. The pattern is also preventable. It can be interrupted by the deliberate investment in knowledge maintenance, by the sustained commitment to training and apprenticeship, and by the recognition that the knowledge is as important as the monuments it produces, and that the failure to maintain the knowledge will eventually mean the failure of the monuments. The Black Pyramid is the warning, the Great Pyramid is the possibility, and the distance between the two, the 8 centuries of knowledge loss that separates the peak from the decline, the solid stone from the crumbling mud brick, the structure that endures from the structure that dissolves, is the distance that every civilization must cross if it fails to maintain the knowledge that sustains its greatest achievements. The Pharaoh Amenemhat III ruled for roughly 46 years, one of the longest reigns in Egyptian history, a reign that was marked by prosperity, by stability, and by a building program that was ambitious, even if its results were compromised by the limitations of the diminished tradition. Amenemhat III was not a failed pharaoh. He was a successful ruler who managed the economy effectively, who maintained the security of the state, and who invested in monumental construction that reflected the highest ambitions of the Middle Kingdom. The failure was not his. It was the traditions, the building tradition that had lost the knowledge it needed to fulfill the pharaoh's ambitions, the tradition that could produce the form of a pyramid but not the substance, the appearance but not the reality. The pyramidion sits in its museum case in Cairo, dark stone, carefully inscribed, beautifully proportioned, designed to crown a pyramid that was never used for its intended purpose. The pyramidion is the most tangible relic of the Black Pyramid story, the one element that has survived intact, that still looks as it was designed to look, that still carries the inscriptions and the religious formulas that Amenemhat III intended to place at the summit of his eternal monument. The pyramidion is also the most poignant relic, a crown without a king, a capstone without a pyramid, a finishing touch on a building that was never finished. The lesson is clear. The lesson has been clear for nearly 4,000 years. The lesson will continue to be clear for as long as the pyramidion sits in its museum case and the mound of eroded mud brick sits on the Djoser plateau. A lesson about the fragility of knowledge, the vulnerability of institutions, and the consequences of allowing the knowledge that sustains a civilization to decay. The trajectory from the Great Pyramid to the Black Pyramid is the trajectory that every civilization fears, the trajectory from peak capability to diminished capability, from solid achievement to compromised imitation, from the knowledge that builds monuments that last to the knowledge gap that produces monuments that fail. The trajectory is not inevitable. It can be prevented by the deliberate and sustained investment in the institutional structures that maintain the knowledge. But the trajectory is natural. It follows the natural tendency of institutions to erode over time, of knowledge to attenuate across generations, and of the specific, practical, experiential understanding that produces great achievements to fade when the conditions that generated it are no longer maintained. The Black Pyramid is the end point of this trajectory for the Egyptian pyramid tradition, the point at which the tradition's capability had climbed to the level where the monuments it produced were no longer adequate for their intended purpose. The end point is not absolute. The Middle Kingdom builders were still capable of impressive engineering feats, as the Black Pyramid's substructure demonstrates, but the end point marks a threshold, the threshold below which the tradition could no longer produce the kind of structurally sound, permanently enduring monuments that the religious system required and that the Old Kingdom builders had routinely produced. The stone endures. The knowledge does not. The Black Pyramid teaches that the knowledge is more important than the stone, and the distance between the Great Pyramid and the Black Pyramid, 8 centuries of knowledge loss, written in the contrast between solid limestone and crumbling mud brick, is the measure of what is lost when a civilization allows its most important knowledge to decay. The distance between the Great Pyramid and The Black Pyramid is not merely 8 centuries. It is the distance between knowledge maintained and knowledge lost, between a tradition at its peak and a tradition in its decline, between solid stone and crumbling mud brick, between a structure that endures for 4.5 millennia and a structure that begins failing before it is even finished. The distance is measurable in meters of height, in megapascals of compressive strength, in centuries of survival, and the distance is meaningful. It tells us something about the nature of human achievement and the conditions that sustain it that is as relevant to the modern world as it was to the ancient. The conditions that sustained the Old Kingdom building tradition, the centralized authority, the concentrated resources, the continuous construction program, the unbroken chain of apprenticeship and training were not inevitable. They were created by pharaohs who invested in the program, by administrators who managed it, and by builders who transmitted their knowledge to the next generation. The conditions were also fragile. They depended on political stability, on economic prosperity, and on the continued commitment of the state to the construction program. When the conditions changed, when the political stability ended, when the economic resources were redirected, when the state's commitment to the program was withdrawn, the tradition that the conditions had sustained began to decay, and the decay continued until the tradition could no longer produce the results that it had once routinely achieved. The Black Pyramid was not built by incompetent builders. It was built by talented, ambitious, skilled professionals who were working within the constraints of a diminished tradition, a tradition that had lost the specific knowledge that would have been needed to build the pyramid they intended. The builders did their best. Their best was not enough, and the gap between their best and what was needed, the gap that the 8 centuries of knowledge loss had created, is the gap that the Black Pyramid's ruins have been demonstrating to anyone who cares to look for nearly 4,000 years. The stone endures, the knowledge does not. The Black Pyramid teaches that the knowledge is more important than the stone, because the stone without the knowledge produces a mound of rubble, while the knowledge without the stone produces the possibility of rebuilding. The Great Pyramid was built by knowledge. The Black Pyramid was built without it. The difference between the two. Standing on the same plateau, visible from the same vantage point, separated by 8 centuries and by the immeasurable distance between what was known and what was forgotten, is the difference that knowledge makes. And that difference is everything.